Welcome to AWS Masterclass for Data Engineers with Project. In this video, you will learn about major services required for data engineers on AWS. Not only that, you will also get hands-on practice and you will build this amazing project. This project is about YouTube trending data pipeline. We will extract the data from real-time YouTube data API. We will have a static data set that will be ingested onto Amazon S3. We will be using Medallion Architecture, bronze layer, silver layer, and the gold layer. Once we have our raw data added, we will explore that data using Glue crawler and put the life cycle so that it goes back to Glacier after some time. After that, we will clean our data into the silver layer. So we will use AWS Lambda to process our raw JSON data that is coming from YouTube data API and the static data set from the Kaggle. We will also have a AWS Glue running on Apache Spark that will process our CSV and JSON data. Both of this will transform our data into the Parquet format. That will be added onto the silver bucket on AWS S3, and we can explore that using Glue Catalog and Amazon Athena. Before putting our data onto the gold layer, we will do a data quality check. So we will write our data quality check logic into AWS Lambda and we will attach AWS SNS, simple notification service, to get the real-time notification of our data validation. So in case something wrong happens, we will get the email about our data. After that, we will transform our data from silver layer to the gold layer if everything is fine into three different categories or three different tables: trending analytics, channel analytics, category analytics. That will also be added onto the Amazon S3 gold bucket and catalog so that you can explore it. Now you can use Amazon Athena and QuickSight to visualize this. Once everything is done, we will use AWS Step Function to orchestrate the entire thing from ingestion to transformation, data quality check, aggregation, and final success notification. This video is your AWS Masterclass for data engineering with industry grade project. So like this video if you find this helpful, and without wasting time, let's get started. So let's start by understanding what we are going to do in this project. Now, this is the project about YouTube data analytics, and this project we have done. If you have been following me from the last 4 to 5 years, you will already know we have done this project previously around 4 years back. And that project was pretty simple, right? So if I show you, this is also available on my YouTube channel. It is like 1 hour, 2 hour of the project. There are two parts of it. So you can see the entire project available here. Now, this project is built using old concept and built using the old AWS UI. A lot of things have changed, and people are finding it very difficult to execute this project. And the goal of this video is not to just do this project, is to give you the entire AWS masterclass. So what we will do, we will learn about AWS concept, okay, while executing the project. So usually what happens is that, let's say if you want to learn AWS, you will learn individual services one by one and you'll keep learning, and you learn about theories, you might do some hands-on practice, but it will be very difficult for you to understand the entire picture and how all of these services work together. You might do a one project at the end, but we are going to take a different approach here, right? What we will do, we will learn AWS while executing the project, and there are few places where I will act like I don't know anything, right? And I will try to learn with you. Okay, so it's sort of like you are learning something with someone. It's like a peer-to-peer learning, while I will also learn and I will teach you whatever things I know. If I, let's say, if I face any errors or if I don't know anything, we will try to understand all of these things by reading documentation. We will use AI to write code. We will do a lot of things. So this will be like the entire masterclass where you will be able to learn and understand, and also how to learn new things with me. Okay, so fully value packed video. I hope that you watch till the end so that you get most out of this video, and do let me know how you like it. Okay, so let's start moving forward with our video and understand what we are going to do. Now, if you know, okay, this was the old architecture we executed around 4 years back. It was very simple. We extracted data from the Kaggle, okay, about YouTube data analytics. We loaded that data onto the Amazon S3. Now, if you don't know about any of these services, that is all okay. We have notes available over here. We have PPTs also where I will explain you all of these different things from the basics. So totally okay. If you don't understand, just stay with me. Let's go with the flow. Okay. And everything will start making sense as we move forward. So don't worry about it. Okay, so we used to upload our data onto the this Amazon S3. Once that is done, we had three landing zones. So one is our landing zone where we put the raw data. Then we clean our data a little bit and put it onto the S3, and then we do the analytics on top of it. Okay, this was the architecture we created. We use AWS Glue to write the transformation job for our in Apache Spark. We use AWS Lambda to do the basic cleaning of the data, data catalog on AWS Glue to create a table on top of the file, Athena to start writing SQL queries. So this was the overall overview. This project is still available on my GitHub. If you want, you can go and see that. Okay. So this is what we did like 4 years back. Now we are going to, let me just put this over here. Okay. Now what we are going to do this. Okay. Here we have added lot of things. Now this project was very basic. This project covers lot of different things. We will be using here we were just using simple static data available on Kaggle, but now we will integrate YouTube data API onto our project, and then we will load that data onto the X3. We will use same data set that we use as a Kaggle data set to put that data onto the S3. Okay, we will have a life cycle created, so anytime we don't need any data, we will put that back to the Amazon Glacier. Again, you will understand all of this. Just look at the overview. We will execute each and everything one by one. I will explain you in detail what we are doing. Okay, then we will run a glue crawler on top of it. That is basically, if you want to run SQL queries on top of the existing files, you can easily do that. Okay, then this is a bronze layer, so we'll use the Medallion architecture to create our entire project. Bronze is our raw data. After that, we have the silver layer. Here in the silver layer, we will do the basic cleaning of our data. So we will have a raw JSON, and then we will transform that raw JSON into the Parquet file. We will read our CSV data or the JSON data from here, and we will transform that into Parquet file, and then we will put that onto the silver layer of our bucket. Okay, then we will do the glue catalog so that we can start running SQL queries. After that, we will do the data quality check to make sure all of the data that is coming to us, okay, are in the right format, that there are no nulls. Based on the validation, we will put all of these data into the right quality. So we will also understand about the data quality. Okay, we will also have a notification system created so that, let's say our data quality does not match, or there are any issues, or it is successful, we will get the email notification on our mail that okay, this particular pipeline has failed, this is the issue, and we will get all of the notification. After that, we will do the Apache Spark ETL, where we will build the aggregation layer where you can analyze all of these different things, and we'll create a catalog for that also, and then we can analyze this data either on Athena or QuickSight. Now, if you don't understand any of this service, totally okay, don't worry, I will explain you one by one. This is the video about AWS Masterclass. If you want to learn about AWS from the scratch, this is that video, okay? But we will use advanced level investigate project to understand that. So you learn both of the things in just one video. Okay, and we will also use the AWS Step Function. It is like Apache Airflow. If you want to orchestrate all of this entire thing into a simple pipeline and run it together, we will do that. Okay, so this is the uh, entire architecture that we will be executing. Now, this is the project overview. And usually, when you do any project, you need to have a problem statement. Like, why are you doing this particular problem on the first place, right? Uh, every data project has a goal, and the project's goals usually include solving a business problem. It can be like, finding the bottlenecks, generating revenue for the businesses. There are a lot of different things available. So we will start with assumption or hypothetical scenario that there is a client, okay, who has a problem. Okay, so the requirements are like this. Okay, they are launching a data driven campaign. Okay, and they have chose YouTube. Let's say they have a product that they want to sell and run a marketing campaign online, and they chose that YouTube is the best platform for right now. Okay, and they want to answer these questions such as how to categorize videos based on the comments and statistics, what are the factors affect how YouTube videos will be popular or not. Okay, so these are the some initial questions they have, that okay, I want to run a campaign on YouTube, and these are the things that I want to find before running the campaign. Why YouTube? Again, YouTube there are like top three most visited website. One is the Google, YouTube, and the Facebook. Okay, YouTube comes second. It owns a lot of video traffic also. So YouTube is the best platform if you want to run some ads. And based on the client requirement, they are choosing YouTube. Okay. Now these are some of the goals of the project. Again, we have discussed this previously also, but let's revise it. We want the data ingestion automatically happening. We want a data lake right now so that we can build architecture. Again, in this scenario, we will build the Medallion architecture. In previous one, we just build a simple data lake. This will be the Medallion architecture. I'll explain you what Medallion architecture is. Don't worry. Okay. Then we will be using AWS cloud. We need ETL, scalability, and reporting. So these are the basic criteria. Okay, so this is the overview of what we'll be doing from the project side. And while we do the project, we will also understand about everything around AWS. So what are the services available, what is important for data engineers, and all of the other things. Okay, so now let's start that, right? Let's start by understanding AWS Masterclass. Now, if you want to take notes, take out pen and paper. If you don't, we also have notes available here. Okay, onto datavidya.com/learn on the cloud and infrastructure. You can go here and we will be reading some of the things from here also. We will also refer PPT that I've created, so you can go back and forth of the different things. Okay, now uh, let's discuss this also, right? This is the AWS video, so we'll be talking about AWS. But usually people have confusion about should I learn AWS, GCP, or Azure, and this is the common question everyone has. Let's say you decided to learn cloud, okay, and you have three options available. One is AWS, second is GCP, and Azure. Now within few minutes, okay, if you start exploring, you will understand there are hundreds of services available on each of the cloud computing platform, and you start getting confused that okay, which one should I learn first? Should I learn Azure? Should I learn AWS? Should I learn GCP? This is the common confusion everyone has, right? You'll be thinking, okay, if I learn Azure, and if I need to, for the job interview, if I need to prepare for AWS, then I will waste a lot of my time learning Azure. This is the common problem everyone faces. But here's the thing, okay? This is the cloud market, okay, in 2025. AWS owns 32% of the market share, Azure 23%, and GCP 12%. Okay. Most of the job listings are around AWS, okay, 60%. Worldwide, most of the startups starts with the AWS. AWS has been market leader from last, I don't know, 5 to 10 years. If you check the Gartner quadrant, Gartner Cloud Magic Quadrant, okay, this is the company that ranks different cloud providers. And if you see, let's say in 2025, if I zoom this, okay, AWS, Google, or Microsoft are the leaders, and Oracle is coming. Okay, so this is the uh, top cloud platforms. Now, what I mean is, if you learn any of the cloud from the three options, you are in the safe zone. Okay, because there are more cloud available like Alibaba, IBM, Tencent, Huawei cloud. These are based on the company use case. So if you're applying for a company and if they are using this cloud platform, then it makes sense to learn them. But usually if you learn all any of the cloud from here, you are in a safe zone. Now the thing is, you don't have to learn all of the cloud platform. That's the number one confusion people have. Like, do I have to learn three of them? No, you just start with one and master one cloud first. Once you have mastered, it will be much more easier to transition into any other cloud because all of this cloud platform works on the same foundation. For example, object storage, right? Object storage is a way to store any of the data onto the cloud. On AWS, we have S3. On GCP, we have GCS. And on Azure, we have ADLS Gen 2. Okay. So this is similar services. They work on a similar concept or the foundation. The service name, UI, all of will be different. Maybe the feature pricing will be different. But the core concept that this is an object storage, okay, is the same. Same goes with the data warehouse, right? AWS has Redshift, uh, GCP has BigQuery, Azure has Synapse Analytics. Does the same work, okay? This might be a little bit better from the cost wise, UI wise, the feature wise, but they do the similar job. Same goes with the serverless ETL, managed Spark, streaming, orchestration, all of these different categories, right? Capabilities or categories you want to call. Each of the cloud computing platform has a service available for that. And based on the service, okay, if you learn this, it will be very easy for you to transfer here and here because you understand, okay, object storage available on AWS S3 is same as GCS, right, on GCP. So you can always have a understanding, the foundation understanding about the service, and it will be very easy for you to transition your career. Okay, so simple answer, if you're learning AWS right now, if you're watching this video, that means you want to learn about AWS. So this is a good place to start if you're just learning. Okay, so we'll go forward and start executing and understand about the AWS cloud platform. Okay, so AWS Masterclass. Now, again, if you already know some of this, you can revise it, you can skip it also. But we will start with the introduction of the cloud computing. Before you learn about AWS or GCP or Azure, you need to understand what cloud computing is. So we'll quickly skim over you. So we will quickly look at it. We will not go in depth about all of these things because we want to learn about AWS and execute our project. But we will start by understanding all of this. So cloud computing is on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying and maintaining physical servers, data centers, you access the technology on as-need basis from the cloud provider. Simple, okay? Let's say if I want to host a website, I need servers, I need RAM, storage capability, networking, power supply, all of these different things I will need. Either I can build it or I can rent it. So cloud is basically someone has already built all of this for you. They give you this UI. You can always go on the UI and access those things differently. So for example, if I have to show you example here itself, okay, let's say we have EC2. EC2 is the Elastic Compute Cloud. Okay, it is simple like a virtual machine. So a machine is running some, it's like my laptop. Okay, you can do a lot of things on a laptop. You can, play games, you can host a website, you can run something. There are browse internet, all of these different things you can do. Same as if you create a EC2 machine, it's like a virtual computer you are creating. Okay, and you can host different things there. If you can, even if you want to play games, you can run a window machine and you can do that. Okay, so this is where our data with their website. So this website that you see is running onto one of the EC2 machine here. So this is our staging server, this is our prod server. Okay, so this is our production servers are running, and this is our Terraform and labs that we are building. Okay, so this is where our machine is running. So it's pretty simple. Okay, we create a machine, we host all of the our things and put it over here. So this was one example of cloud computing, that we are renting server from them so that we can run something. Okay, let me do this. Go here. Now, cloud computing platforms provide services to us in three different forms. One is infrastructure as a services, they give you infrastructure as a rent. Second is a platform as a services, they give you some kind of platform so that you can do your work. And third is a software as a services, where you can get access to different software and do the work. For example, infrastructure, instead of building again the your own computer or own machine, like by buying RAM, storage, power supply, all of the things, you can rent the infrastructure from them. Okay, and the renting basically means, if I show you cloud data centers, you will see all of these are the data centers created or developed by all of this cloud platform. And let's say if you hypothetically, if you, let's say, run one EC2 machine, so from this rack there will be a small place assigned to you automatically via software, or they have written all of the logic, and you will be able to access the small machine based on the configuration and do your work. So basically you are accessing their infrastructure via internet, and then doing your work. So instead of building all of these systems by yourself, you are getting the infrastructure as a service, okay, from them. Let me close this. Let's show. Yeah. So this is infrastructure like EC2, S3, VPC, Azure VM. All of this comes into the infrastructure, like hardware things. Then we have the platform as a services. So platform for building and deploying application. Now there are a lot of services where I don't want to worry about the infrastructure. I just want to care about my code and running it. So by in the case of EC2, you have to manage everything by yourself, like hosting your website, making sure the number of amount of storage that you need, RAM you need. You have to put all of this into the configuration. But there are also cases that you don't want to worry about, uh, all of these, like management of the infrastructure side. You can also go with the platform as a services. So there are like examples is Google App Engine, Elastic Beanstalk. AWS Lambda is also a platform as a service. We will understand about that, so that you don't worry about the compute or resources. You just worry about your code. And then we have the software as a services. This is basically a software product provided by the company. So You can access it via web browser. You manage your data and preferences. For example, you use Gmail, Slack, Salesforce, Dropbox, all of the software that you use online. This is called as a software as a services. People call it SaaS. Like if you are into tech or if you are quite active on Twitter, you will know like, oh, I want to build a SaaS startup, right? SaaS is basically software as a service. You want to give a service via software to any client. Okay, so this is the basic of cloud computing. So you can again what you manage there are different responsibility. For example, on premise you have to manage everything from application, data, runtime, middleware, all of these different things you have to manage. But on infrastructure you will be managing application to OS and the main hardware level such as networking, storage, server, virtualization will be managed by the provider. In the platform you will be managing your application and the data, and all of the other things such as runtime, operating system, server, storage will be managed by the system. And the SaaS, they will manage everything. You don't have to worry out, like you don't manage like Gmail by yourself, right? All you do is use Gmail, or you don't manage like say Dropbox or Slack, you just use that, right? So in the software as a service you just use the application, you don't manage anything. So again, three different services provided by the cloud. Again, the foundation, if you understand all of this, things will start clearing up. Okay, so infrastructure, platform as a service, software as a service. Now let's talk about AWS. Like what does AWS provides us? Now AWS is the world's most comprehensive and broadly adopted cloud platform. Most of the startup that you see are on AWS. So if you are someone who want to work in startup, AWS is a good place to learn. If you are someone who wants to maybe work in a banks, there are a lot of banks who use Azure also. If you are someone who wants to work in corporate, people use different. So clouds, people use different cloud based on the uh, companies use different cloud, right? Based on their requirements. So whenever you're applying for a job, the best is you research about the company. Okay, let's say I want to work in Cred or Zomato, or let's say any of the company that you are interested in. First, look at what cloud computing platform they are using on the first place. Let's say Zomato is using AWS. So it makes sense to learn AWS because you will have a higher chance of getting hired. Okay. So AWS was launched in 2006, started with S3 and EC2. Okay, it has now 200 plus fully managed services available. Serves millions of customers, like from startups to Fortune 500. Market leader with 31% cloud market share. Okay, ahead of Azure and GCP. It also has a pay as you go, so you only use or only pay for the things that you use rather than paying for entire thing. And it has a global infrastructure. We will understand about this part right now. Okay, so it works on the main scalability. You can easily scale up, scale down, reliable. It runs across multiple availability zone, cost effective, and global reach. Now, this we already saw. Okay, this is the Gartner quadrant where AWS is a market leader, but again, Google and Microsoft are also there in the same quadrant of the leaders. So of course, if you want to stay safe in the cloud market, you can learn any of one and you are good. You are good. Okay. Now let's understand about the AWS global infrastructure. How does the AWS, again, I told you, right? This video is about the AWS. So I want to teach you AWS, but I also want to teach you how to execute project via hands-on. So this is not just a theory. We will also learn theory, but also hands-on thing. Okay, so what is Amazon Web Services? We already know. Okay, world's most comprehensive cloud platform, has 200 plus services available, pay as you go model, market leader. We already know this. Okay, other than that, it has 200 plus services available, 32 regions, 102 availability zones. Again, it keeps changing, and 450 plus edge location. If you want to get the latest data, you can always go to the doc. Now let's talk about what is AWS region. Okay, there are three things. One is a region, second is the availability zones, and third is the edge location to understand how AWS is built. Now the region, okay, AWS region is a physical geographical location. For example, US East, AP South. Okay, this is like a physical area. Like in India, there might be inside the Mumbai region. They have given a this sort of name like AP South one, US East one. So these are different region located. So each region is fully isolated from the other region. So there is a data center here. There is one data center here. These are different. From each other, like there'll be one in India, maybe into some Indonesia, I don't know, Okay, there will be one in India, Africa, maybe in US, Canada, all of these different region. Okay, in one country also there can be multiple regions. So in India it can be like in Mumbai or in Bangalore. Okay, it can be a different regions available. So based on that, they create their all of the physical resources there. So choose region based on the compliance, latency, service available, and pricing. Not all services are available in every region. So if I go to AWS console and if I click here, okay, you will see there are different region available to me. Okay, there is United States. So in US we have like these many regions available. Then inside the Asia we have these many region available. Inside the Canada we have these many region available. So these are the different region. This is just a country name, but these are the regions. Okay, US East 1 2, this is their way of writing it, but you can also look at the by the state wise. Okay, so these are the different regions available on AWS. Okay, got the region. What the regions are basically where they actually create the data center. Within the region there are different availability zones. Okay, so one or more discrete data centers within the region. So there will be one availability zone, second availability zone, third availability zone. So each AZ has independent power, cooling, and network connected via high bandwidth low latency private links deploy across multiple AZ for high availability and fault tolerance. So what this means is that, let's say I am inside here. Okay, so this is my, let's say, entire AWS, and I am inside, let's say, uh Mumbai region. Okay, this is my Mumbai region. Now in the Mumbai region I will have different availability zones. Okay, this is AZ1, AZ2, AZ3, AZ1, AZ2, AZ3. This basically means these are the different data center. Okay, and these are very separate from each other, right? So inside the Mumbai region, all of these AZs will be hosted nearby location, right? So this will be one data center, this will be one data center, this will be one data center, and these are separate but within one region. So if you want to deploy, let's say, high available application onto Mumbai region, what you will do, you will deploy, let's say on AZ1, it deploys on AZ1. You can replicate the same data over here also. So in case if this AZ goes down because of fire, earthquake, or whatever happens, this will be always available to you. So within the same region I can have my backup available. So this is like a three different data center inside one region. This is what we call as a availability zone on AWS. Okay, understood? We have region which is basically a different places available. Inside that region we have multiple data centers, right? Availability zone 1, this is one data center, second data center, third data center. Data center, again I show you, this looks like this. So this will be one place, and then like this there will be a second place at different location within that region only, and the third place. Okay, like that. This is your availability zone available on AWS. Okay, and the third is edge location. And now let's say you are watching Netflix. Okay, and the Netflix is releasing one new web series, and it is hosting on their server. Okay, let's say on the US server Netflix is hosted. Now if you are trying to access that video from India, it will take very long for that it to travel and give you the entire stream data on a network. Okay, you will have face delays, or it will keep buffering if you are accessing data from here. So that is to overcome that. Okay, all of the content delivery network, you call it as a CDN. Okay, used by CloudFront. There are different edge location. Okay, we might not know where the edge locations are on AWS. You can find it on the website, but there are different edge location near to your location. So let's say you are staying in India and there is a edge location near Mumbai. So what will happen? AWS in the backend, okay, will cache all of the data of the streaming onto the nearest edge location available to you. And whenever you are visiting Netflix, okay, whenever you're trying to access any data, it will directly route traffic to the nearest edge location rather than going to the main server. So this is the concept of edge location, that to give you the content very faster. Okay, so that the experience is much better. Okay, so cache content closer to end user for the low latency. 450 plus point of presence available worldwide, used by CloudFront CDN Route 53 DNS. AWS Global Accelerator also uses edge location. So This is basically a for the caching mechanism. So if you have a software background, it will be quite easy for you to understand. But in the simple way, it is the way you can get the content faster because it is stored near your location. You don't have to get data from the US or wherever the actual servers are hosted. Okay. So uh the three things we understood. We have AWS region. Inside the region we have availability zone, and inside the zone inside the so we have AWS region. Inside that we have the availability zone, basically different servers, and then we have edge location spread across the entire world that gives you content faster. Okay. Now this was mainly about how the AWS is managing the data center and everything. Now how does the AWS account work, right? When you create AWS account here on the this is what is the structure of this account, because each cloud provider has their own structure. Okay, so AWS has its own structure also. Let's look at that. Okay, so AWS account. Okay, this is your root user. Usually when you create a new account, you are creating account with the root user that has full access. You can use MFA that has the full access to all of the services from billing to anything that you want to do. You can use MFA for this, and you should avoid using root access for your daily tasks. Okay, so this is for the root user. Then we have IAM, users and role. Again, we will understand about all of these things. Just stay with me. Okay, I'm just giving you overview of everything. So when we start understanding these things one by one, it will be quite easier for you. Okay, so then we have IAM, users and role. It is used for the access control. If you want to give access to some user or some service, you can do that. We have organization. AWS organization is it is one service used to manage account across the AWS. So let's say you are running a big company of, let's say, 500 people, and if you want to give access to uh, AWS account access to all of these 500 people, you can use AWS organization to manage all of these accounts. Then billing and cost management, and free tier you usually get 12 months free, and there are services that are always free. Okay, so this is the architecture what it looks like. Okay, you have AWS cloud. Inside the cloud you have AWS organization. Then you have the management account where you can admin can grant access to user policies, groups, and manage billing. And then there can be multiple accounts such as student account 1 2 3, from like that it can go to the multiple things. So pretty simple. AWS cloud, inside that organization we have multiple. One is your admin, which is your root account. Okay, and then there are sub accounts that you can create if you want. Okay, so this was all about the core of AWS. Now what we will do, we will start understanding about the services. Now before we understand about services, I will explain you, or I will show you this from overview. So again, if you don't have AWS account, it is pretty simple to create. All you have to do is just go to aws.amazon.com, create account. You can just fill the information here. Okay, and create your account. This will give you $100 in credits, and if you complete various activities, I think this will give you more $100. So uh, they might ask you for credit card initially for the verification, but they will not charge you. In fact, they will give you credits so that you can use AWS and various services. So anything we do in this project, if you have a free trial or the credits available, you will not be charged, so don't worry about it. Okay, so creating account is pretty simple. I don't want to spend time explaining you because it is some basic stuff. You just have to provide your details and you will be able to create your account. Once you create your account, you will be created with a fresh AWS. Right now I have visited a lot of services. My costs are running, so you will be able to see all of the costs that we have here. But this is what the AWS console looks like. And if I go to AWS organization, you can also do that with me if you want, but I don't think you will have organization available. But it looks something like this. So inside the organization, this is my root account. Okay, and inside the root account, I have, like, let's say, students account available here that I created for the test. I have the security and the sandboxes available. So this is where you can manage accounts. Then we have IAM again. Identity access management, again we have a proper section for this right now. Uh, when we do our hands-on practice, but I'll just show you the overview. This is where you can manage users, roles, and all of the other things. Okay, let's continue with our video and let's go to the next thing so that we move forward. Now, till now, I think you understood the core of cloud computing. We understood the core of AWS, how it is built. Now we will start understanding about the different services required for uh, data engineering tasks. Okay, we will be mainly focused on data engineering services only. On AWS, if you go, you will click here, you will see there are hundreds of services available into each of the category for compute, containers, customer support, databases. Like these are the databases supported by AWS. These are the developer tools, edge and user computing available, front end and mobile. You also have services for the game development. You have service for that. Internet of Things, machine learning. You have services for machine learning. Content delivery that we looked about, the cloud front, Route 53. All of these different services are available based on the use case. Now, as a data engineer, we don't need to learn all of these services. Okay, we just need to learn few services that will help you to do most of the tasks. And these are the services that we will start with. We will start with AWS S3. Okay, simple storage service. This is a scalable object storage. So Amazon S3, okay, core concept, let's understand. It is an object storage with 99 it is an object storage with 99.999 nines, okay, durability. Basically, anything you store on AWS, the chances of it being available or it is being stored there is this much high, okay, 99.119. So that it gives you the chances of you losing your data is very less. Store unlimited data, okay, object, you can store unlimited data at one time of the upload. You can maximum upload up to the 5 TB each of that objects. Okay, so if you have, let's say, a video file of 6 TB, it will not go directly. Okay, but if you have up to 5 TB, very less that you will have video file of 5 TB or any of the data. Okay, because most of the data are divided into the different segment and then you upload it. Buckets are region specific, names are globally unique. We will understand that when we do the hands-on. Key value store is equal to, it is a key value store. So key is a object name and value is a metadata. Okay. I'll also explain you this part. Okay. Just right now, understand the concept. It has versioning, encryption, lifecycle, replication. It also has a different storage classes. For example, standard storage class you usually use if you access the frequently accessed data. Infrequent access, so there are data that you might not be accessing, you can move it to infrequent access, so that the storage cost is less here. One zone access, you have single AZ, lower cost if you just want to put your data onto the one zone. Glacier instant, glacier deep, okay, this is basically if you want to archive your data. Instant, you can have an instant retrieval. Glacier deep, lowest cost for storage, but the retrieval costs a lot of money. And intelligent, it will do based on its understanding. Okay, this was the core concept. Again, if you want to go deep dive, I have created the detailed blog here also, so you can go deep here, you can read about it, but I will explain you this concept onto the this via hands-on. Okay, and via hands-on basically means we will do our project. So now we are going to start with our AWS project that we have. Simple technique. We will understand about the basics of services, we will understand what all of these mean. Okay, why, by doing the hands-on practice, so that you also understand what it is while doing the hands-on practice, and we also have a project available. Okay, before we move forward, let's just set up our project first. So if you have any code editor available, you can use that. If you don't have, then you can install the VS Code from online. And what I'll do, I'll open the folder here, and I have a folder created into my documents projects. Okay, I'll open this folder, and inside this folder I will create a new folder. I will put all of my projects here. So let's say the project name will be YouTube Data Pipeline 2026. Okay, I'll just keep the project name. You can do the same with me and work together. So let me close this. Okay, now inside this we will create now inside this we will create one folder. We will not inside here, we will create one folder as a data. Okay, and the data folder, we will store our data from the Kaggle. So again, let me go back to the architecture here. We know that our data sources are YouTube API and the Kaggle dataset that we have available. These are our two data sources. One is our static dataset, and second is our actual YouTube API that we will be integrating. So first we will start with the static dataset. So for that, let me just get the data. What you can do, You can go to, I'll put the link below also for about this. You can go here onto the kaggle.com, and you can go to the, where is that? Yeah, over here. You can data explorer, not here, well, yeah, over here only. You can click onto the download and download the data set as a zip file, and it will download the entire data. Okay, you can do it programmatically also, but this is much easier. You can just download the data as it is, and it will download the data something like this. Let me just see if I have the data downloaded. You'll have to register it. Just create your account. Once you have data registered, I'll show you how the data actually looks. Let me just paste the data itself onto here, because where is that? Yeah, set data, file to paste. Okay, so this is what the data looks. I'll just show you inside. Where is that? Projects, here data. Okay, so this is what the data looks like. Okay, it has JSON data and the CSV data available, and we'll export this data, but it has different countries of categories and the videos available. Let's look at this data. Okay, you can download this and again move forward. So let's see if okay. So we have two data available, and also it is available on Kaggle if you want to have a context here. So it has content. Okay, dataset includes several months and counting of data on the daily trending videos on YouTube. Data is included for US, GB, DE, CA. These are different regions available, such as USA, Great Britain, Germany, Canada, France, respectively, with up to 200 listing trending videos per day. Okay, so these are the data that includes. So they added the new version and added the Russia, MX, Mexico, South Korea, Japan, and India also in this data set over the same time period. So there is one CSV file available. Okay, here. This CSV file includes all of the trending data, such as you have the video ID, trending date, title, channel ID, category ID, publish time, tags, views, like, dislike, all of these are available. If you want to see, you can also open it onto the Excel, or if you are using Mac, you can open it onto the numbers to explore this data and how it looks. It's always the best practices. If you are doing a data engineering project, you should know what the data looks like. Then only you can write the transformation code or the cleaning code by understanding the data. Okay, so let me just wait for this to open. Mm, okay, here it is opening. Let's move forward and understand the JSON data also. So the JSON data is also available. So this is what the JSON data looks like. Over here, you will see we have different categories available, such as film animation, autos, vehicle, music, pets, animal, sports, and all of the other things are available. You can use this category ID, okay, to connect with the ID of this and retrieve the category of that particular video, so that you have the JSON data available with the category, and you have this different information available about the description, rating, comments, thumbnail, links, likes, dislike, views. All of these information are available. Okay, so we have the trending videos available and the JSON data available. This is our static data. So make sure you have your data available over here. So we have our data available onto local storage, and now we want to load this data onto the Amazon S3. Okay, this will be our bronze layer, and again, as we discussed, we will be using a medallion architecture, and this is what it looks like. Okay, very simple. This is just a format of how we want to organize your data, sort of like a standard practice used in the real world. So you have a data available, okay, and you want to serve this data. So what you do is you divide your data into the three different categories. One is your bronze layer, second is the silver layer, and third is a gold layer. Bronze is your raw data as it is ingested onto the platform. Okay, you don't do anything. Wherever you take your data from any source, you just put that data as it is, and you do not touch this data, because anytime you want to roll back or you want to get access to a specific value, you can always get the raw data. Okay, then comes the silver data. Okay, the silver layer, you can filter, clean, and augment this data. So let's say if you want to remove null values, you want to rename something of the column, you want to drop something, you do all of these into the silver. So you read data from the bronze layer and put that onto the silver layer. And then we have the gold level. So you use the clean data to aggregate data onto some kind of level, right? So if I want to aggregate my data based on date or the region, whatever it is, right? I can, based on the business uh, use case or the goals, I can aggregate my data onto the some level and then give the final metrics for the use cases. So this is simple medallion architecture. Okay, you can refer again. You can just search on Google. Also, we also have a notes available here. So if you just medallion architecture, okay, you will find about the medallion architecture. I also have a video on in my course available for that. You can get the details about it if you want to go in Apache Spark. Okay, so this is about that, everything about the medallion architecture. So what I want to do, I have my data available and I want to put that onto Amazon S3. For that, I will have to create S3 bucket. So let's start doing that. Okay, and I also keep this open so that we'll know. Now AWS, just go to the console and write AWS S3, or you can just write S3. If you click here, in your case, if it is a new AWS account, it might not show anything. Anything, I mean, this will be completely empty. All you have to do, first look at the UI. Okay, if you are looking at for the first time, just see what are the things available here. Okay, just get used to the UI. You have buckets, you have access management, something available, some storage things available, general purpose directory, all of these things are available. Totally fine, I don't want to know about it. What I want to do, I want to create a bucket. Okay, again, to create a bucket, it is a region specific and names are globally unique. What I mean by that is that I click on the create bucket, general purpose bucket, uh, global namespace. Basically, they added account regional namespace also now, but we'll go with the global namespace. So let's say if I do the test bucket, okay, and if I try to create the bucket with the test, chances that this bucket name already exists. That means somewhere in the AWS universe, okay, someone created the exactly same bucket test and now I can't use it. So let's say if I do test Darshil, there are high chances that I might be able to create because the combination of this is quite rare. Let's try it. Okay, again, fail to create bucket is already taken. Okay, so this bucket name is also taken. So in our case, we will just create a unique bucket as bronze for YT data pipeline bronze US. Let me see, I am into AP South one. Okay, so we will use AP South one dev. Okay, so this is my bucket name. Now if I use this bucket name, you won't be able to use this bucket name. Right now we are working in the Mumbai region. As per your location, you can change the region here itself right now only, so that you only work on, let's say if you're working from US or any region that you're working on that is nearest to your location, use that. Okay, so this is my bucket name, I'll use that. Choose bucket, I don't want to choose any settings. This is fine, this is fine, everything is fine here. Okay, and I will click onto the create bucket. Okay, so my bucket YT data pipeline bronze AP South 1 dev is created. What I will do, I will copy this and I will paste it into let's say I'll create a new folder inside the this one, or this, inside this new folder, and I will give the name as scripts. Okay, and inside the script, I will create a new file and I will give the file name as uh, let's say information.md. I'll give the markdown file and I'll give uh, let's say bronze bucket name, and I'll store it so that anytime that I want to copy the data, okay, I can just come here and copy it rather than going back and forth from the this. So bronze bucket name is done. Okay, now just like this bronze bucket that we created, okay, we will create a silver bucket and the gold bucket right now only, so that we don't have to come again and create it. So you can copy this as it is. Okay, to make it unique, again, make sure to add your name or some kind of flavor into it for a pattern. Okay, and you will be able to do that. Create the bucket, click on this. I'll give instead of bronze, we will keep silver. Okay, copy this and create the bucket. Then okay, I think This is silver. This is silver. Did I make a typo onto this bronze? BRON bronze. Okay, I think it's fine. This is fine. No, this is my bucket. Wait. Okay, and then we have the gold bucket name as, just copy this, create a new bucket, put it, update the gold, and create it. Okay, so now we have 3 buckets created for us for based on the architecture we have here. Okay, bronze layer, silver layer bucket, this one. Okay, and gold layer bucket that is available over here. So we have the 3 buckets created for our use case. We can create one more bucket. Last bucket that I want to create is to store all of the scripts. Okay, all of the glue script that we will be writing will be here. So we will do YT data pipeline script. Okay, and create the bucket. Again, add your own unique flavor behind this so that it can create a script bucket. Okay, this is done. We have all of these things are available. Now, when we were learning about this, which was AWS S3, we understood about the storage classes, okay, and the storage classes and the this versioning, encryption, replication, and lifecycle. So versioning is basically if you want to keep the multiple version of the particular data. So if I want to, if I keep updating the data, and if I also want to store the different versions of that, you can enable the versioning. When you go here, uh, bucket versioning, there is an option available. Okay, right now it is disabled, but if I enable inside the properties, you will be able to track the different version of the same file, whatever the changes that you make. Okay, so this is versioning. Then we have the encryption. Encryption is also available, I think inside the, where is that, I think permission, where is that, access control, ownership, bucket policy, bucket access, management, replication, properties. Yeah, over here, only inside the properties itself. So we use the default AWS managed S3 keys, okay, SSE S3. But there are different ways you can encrypt your message. Again, in your case, we might not, might don't want to do. Again, in this case, we don't want to worry about the encryption. But when you are going on to the higher and higher level of the corporate, and if they have the sensitive data, they might use their own S3 encryption key or own managed key in order to encrypt the data. But right now, we can use the AWS S3. Then we have the life cycle. Okay, and the life cycle, I want to understand this one, make you understand this one. Okay, so on the bronze layer, okay, we will be storing a lot of raw data as it is. What we want to do, we don't want to store this data forever, okay, because raw data, we use it for the silver and then we do the gold, and after sometimes we might not need old data, such as like 2024 data we might not need right now. Okay, so what we want to do, we want to transfer this data onto the Amazon S3 Glacier. What is S3 Glacier? Uh, Let me do this. Okay, Glacier. Okay, now we already understood about the different classes of S3 over here, which was standard, infrequent. We have one zone, Glacier, Glacier Deep. Okay, so there are different classes of storage available onto AWS. One is a standard, okay, and the cost for that per month is 0.023 cents. It is already used for hot data or frequently queried data. So standard, whatever data that you store, you can always use it based on your demand. Then we have the infrequent access. So there are some data that you might not want to use after a few months. Okay, so data access monthly or less. So maybe I want to use data for the last 6 months, but I might not use it right now. So I can put this onto this standard. Then we have the Glacier instant retrieval. The cost is very less, okay, but you can retrieve it very faster. And the Glacier Deep Archive, the cost is very, very, very less for the storage. This is used for the long compliance. So let's say you can store last 50 years of data, But tomorrow the audit comes to the company like, oh, we want to review all of your data from the last 50 years because you might have created some fraud, or you might be involved into some malicious activity. We want to review all of your data. That is the reason you have to store your data into deep archive for the compliance reasons. Okay, usually banks and all of the other things do this. So in our case, we have put that into our architecture also. Over here, we have the life cycle that puts our data onto the Amazon S3 Glacier. So we'll do that also. Okay. So all you have to do is go to the management of your bronze. So this is my script. Okay. Go to the bronze. Over here, AP South one, inside management, and click onto the create lifecycle. This is what we were looking at here. The lifecycle auto transition between the storage classes. I want to create a lifecycle, enter the rule name. So rule name, let's say archive old, archive old raw data. Okay. Prefix, let's say we will do YouTube slash, okay, anything data related to YouTube, I want to archive it. Then there are different rules such as transition current version to the different object classes, transition non-current version, expire current version, permanently delete something, delete expire object. I will click on to this. So this is the standard intelligence. So what I want to do, I want to click onto the glacier flexible retrieval, okay, for formerly glacier, and after 90 days, okay, I'll create this rule. I can add one more if I want to do deep archive, but I'll remove it. So what I will do, I want to transition my current data, okay, over here inside glacier flexible retrieval after 90 days, okay, and I will create this rule. Okay, let me just acknowledge this. I'll create the rule. So after 90 days, okay, any raw data that I upload here inside the slash YouTube folder, all of this will go to the this one, which is this instant retrieval, so that I save the cost, okay, and I can retrieve the data for the longer without incurring a lot of cost. So this was the quick masterclass of Amazon S3 that we understood. Okay, now what is the next step for the project? Okay, we understood about the S3 and most of the things we looked here also. The core concept, however, what this is, and storage classes, and how to actually use that, the life cycle to go between the storage classes. So now we have our data available onto the data. We will write a small script for this, a simple bash script, AWS underscore copy dot sh. Okay, inside this, we will have something like this: AWS S3 copy, okay, and the file name, let's say the file name is ca videos, vid videos.csv, okay, then s3 slash slash, I want to see my bucket name, which is this one. This is where I want to store slash YouTube, okay, slash raw statistics. This is raw statistics slash region is equal to, this is ca, okay, and slash. So this is where I want to store this. Now let me explain you this also, if you are very new. So on AWS we have AWS CLI, AWS CLI. This you might have to install. Not here. Okay, AWS CLI is pretty simple. You will find a download option somewhere here. Where is that? AWS CLI. Just do the download. Maybe on install onto Mac or Windows. This is the CLI version. This is, you can do on Linux like this, I think. Wait, let me do Windows. You can download it from here, the installation, or if you're on Mac, you can download from here. This is the package available also, GUI installer, if you want to do that. Okay, basically if you install this, and if you go to terminal, I can do AWS help and it will give me the entire command. For this, again, I'll have to show you the setup also. Wait, let me. So if you want to understand how to install AWS CLI on your local PC, just go to ChatGPT and write how to install AWS CLI in my local uh, Mac. Okay, and this will give you the entire instructions on how you can do it. You can run this script, you can install this entire thing you can do. And the main thing, after you install, you can just write AWS, and if it gives you something like this, means AWS is there. You have to do AWS configure command. If you click on AWS configure, you have to provide your access key, secret key, region name, and simple. Okay, you have to provide these. Where do you get this? For that, we will have to look at IAM. Okay, let me open the IAM now. You can also do this with me. So what we are doing is that simple. Right now, our data, okay, data is on local PC. Okay. Now I have multiple options if I want to upload this data onto the S3. One is write Python script. Okay. One option is I can directly upload this data, upload data directly. Okay. Or I can write bash script /CLI. Okay, I can do this. These are the three options, and then I want to upload this data onto the S3 bucket. Okay, this will go from here. These are the options available here, here. It will go here, here, like this, sort of like this. Okay, so I can upload my data three different ways. Again, there are multiple ways, but these are the Python script direct upload data. If I want to do, I can just click on to upload and dump all of this data as it is. But I want to store my data into proper structure, that is, inside the YouTube folder I have created raw data, and for each region I want to store my data for the partition basis. Okay, and the concept of key value, okay, this we understood. The key is my object name and the value is the actual data available. So when you say AWS object S3, okay, object basically means, this is quite tricky to understand, but when you upload any data over here, okay, it is considered as an object. An object consists of two things. One is a key and one is a value, that we understood here. One is a key, this is object name, and one is a value. What is key? Key is this entire thing. Okay, to reach, it might look like a file format which is like ///, but it is not of actual file format. It is an object consists of two things. Inside the object you have two things available. This is the key, okay, where the objects are actually stored, and this is the actual data, that is a value. Okay, so when we do that, when we do upload the data, you will understand this. So for uploading data by your local PC to AWS, what you have to do is you have to go onto the user on IAM and click onto the create user and give the username as AWS CLI local, something like this. Okay, and I don't want to provide the programmatic access. I can click on the next. Okay, I can attach the policy and I can give the policy. Wait, this is loading. I can directly give the admin policy for this right now, and I can just click on the create user. Simple. Now I can go to AWS CLI, go to security credential. Okay, and click go here, access keys. Access keys are available. Okay, so you can go to the access keys and you can click onto the create keys. Now it will ask you what is the use case that you are using, but I want to go for this CLI. I understand, and I want to go next, create access key. This will give you the access key and the secret key. Click onto the download CSV. This will have your keys available over here, and click onto done. Now go to your terminal. Let me clear this. Write AWS configure, click enter. You can paste your access key here from the file, secret key from the file. Write the region name here, AP South 1. Output format none, enter, and you have configured AWS in your local PC. If I do AWS S3 LS, it will show all of my bucket that is available onto my S3. So you will see AWS Glue AP South one that we created. Then there might be bronze also available. Where is that? Yeah, YT data pipeline available here. Bronze, gold is available here. Script is available here. Silver is available here. So all of these are available to us. Now, once what we did, we just made a connection of our this local PC to AWS using CLI. Now using CLI, now we can do anything onto AWS. You can also create bucket, you can delete bucket, you can do a lot of things. So instead of going to AWS console and doing things, you can do it on the CLI level. I can list bucket, I can go inside the bucket, and I can also upload the data. So this is what we will be doing. What I will do, I will go to the CD documents projects. Okay, inside I have YouTube data pipeline. Inside that I will go 3D data. Let me just clear this. I will do ls. Okay, now all of these data are available. What I want to do, I want to run this. Okay, I want to upload this CA video CSV. So I will paste this AWS S3, copy this particular file to this particular location. I will hit enter. Okay, now it starts uploading the data. Completed 70 MB of 61. This is my speed, one file. Okay, you can also go to the console here. Okay, once this is complete, you can just refresh this and you will see the data available. Okay, let's just wait for this to complete. Okay, just drink the water. It's already 1 hour. I think you can also drink the water. Okay, so our data is uploaded. If I do refresh, you will see YouTube folder, you will see raw statistics, you will see region, and there is a file created. Okay, now this entire thing is called as a key. This is object. Okay, when you go back, okay, this is object, which is basically what we talked about. It is key value stored. So key is object name, value is our data and metadata. So this entire thing, I think even the name of this can be considered as a key. Okay, and the object is the actual content that we talked about. This is this available onto the inside the file. Okay, all of these are the content. Okay, now we have to repeat this for all of the things. So I have already written that. If you want, what you can do, let me just get this. For this I'll do paste here. Okay, so for even JSON, I have this bucket name. Make sure the bucket name is fine, YouTube, and this is raw statistics, reference data, regions here, same format. Okay, I can also do this and run it onto the terminal. CA JSON ID upload. Let me just go back YouTube. Okay, reference data is available here also. Okay, so both of the JSON file and the CSV file is available now, but we want to run this entire query. Okay, for both of the category of the data available, and for that what we will do, we will go to the chat GPT. I will copy this. Okay, and I will ask, can you uh, give me this command for all of the files that is available. Okay, I'll paste the command available in the same format for CSV and JSON. And what we need to do is that, let's say we can either get the screenshot of this. Okay, these are all of our files available. So what I can do, I can just share the screenshot to ChatGPT, copy this, paste it here. So one way is you can write all of these things manually one by one, or other way you can actually just use ChatGPT to do the same thing. Okay, so it will do entire thing. So it will give me the entire command rather than me writing all of these things one by one. Simple. I copy this and I'll paste this directly onto my terminal, and it will start uploading the files again and again. Now it also has this same CA video. So what it will do, it will just rewrite the file, okay, instead of duplicating it. So this will run in the backend. Same goes for the this. So what I will do, I will just put that onto, you can just put that over here itself on AWS copy, uh, here, and the same for this. Okay, so both of the copy commands are available here. So I'll just wait for this to finish. Once this finishes, we'll move forward with the video. Once all of the files are uploaded, you will see them inside your bucket, bronze bucket, inside YouTube raw statistics. All of the data will be divided based on the region itself, so that we can easily access the data. Okay, so till this is happening, okay, let this happen in the backend. We can move forward, right? We don't want to wait for this. Right now I have some internet issue, that is the reason it is uploading a little bit slower. So I'll wait for that till this happens. If so our data is being uploaded. What we can do, we can learn about all of the other data storage available onto AWS. Okay, so after S3, okay, we have EBS and EFS, which is, one is a block storage and one is a file storage. Okay, EBS, elastic block storage, and elastic file storage, these are the two storage mechanism available. We might not be using this in this video, but again, this is the AWS masterclass video, so it's good that you understand these two storage classes also available. So AWS EBS considered as a block level storage volume for EC2 machine. Okay, attached to single EC2 instance, available onto the same AZ, persistent, independent from the instance lifecycle. These are different types of EBS available, such as GP3, GP2, IO2, ST1, SC1. Snapshot for backup store, snapshots for backup stores in AWS S3. So S3 is an object storage used for objects, like we understood the key value pair, it stores that way. EBS usually used with the AWS EC2, right? When you create a machine with the laptop, we also have a storage available, which is the hard disk that is attached. Okay, like that onto the EC2. If you want to attach a storage or a block storage, you can usually use AWS EBS. Then we have EFS. Okay, this is NFS file system. What is network files storage? I think NFS full form. Let me see. NFS on AWS. I think network. It is network level file storage something. Uh, yeah, network file system. Okay, uh basically disk that is accessible via network. Okay, fully managed by AWS. It is a file storage like on our PC, right? We have different file system available where you go inside the folder, then inside the folder you can store the different folders and then store the file. This is available via the network, so you can connect or you can attach sort of like a external hard drive. You can think of it that way, that instead of connecting it via wires, you can connect it via network. In the backend, it might be doing it on the physical layer, but via the network, it looks like you are sharing data over the network, right, over the internet. With this file storage, you mount it with your EC2 machine or any of the storage any of the machine that you have, and you can share it across the different EC2 also. So this is fully managed NFS file system shared across multiple EC2. It is like one storage that can be accessed via all of the EC2, automatically scales the storage, mostly available for Linux. Okay, these are two modes, like general purpose and max IO. It also has the storage classes and lifecycle management for cost optimization. This is quite expensive. EBS is a block storage. Again, you if you want to go into deep of all of this, you can always read the documentation. You can read the notes we have available if you want to go into the storage. But I just wanted to give the overview about this because we are not going to use this. But understand the storage. Inside storage, we have S3 object storage, EBS as a block storage, and EFS as a file storage available. Okay. So let me just look at this. So my CSV files are copied. Let me copy this JSON files also. So I'll go here. If I refresh this, you will see all of the files are available. If I go back in the raw statistics, all of the files are available for this also. So this is done, right? If I go onto my architecture, this is done. I have uploaded my data using simple script onto the S3. We will do this. Don't worry about this, but this is, we have the data available. Now, let's go to the next step. Okay. We are using AWS Lambda. We are using AWS Glue. A lot of different services that is connecting with each other, right? We have AWS S3 available. So AWS Lambda will read data from uh, AWS Lambda will read data from AWS S3 to extract the data. AWS Glue, okay, will read data from S3. So inside the IAM, we looked about creating a IAM user. But there is one more thing that is called as a IAM roles. Okay, we looked about user. User is basically anyone who you want to give access to AWS console or the keys so that they can access it. Then there is roles. IAM role is the identity you create specific permission with a credential that is valid for short duration. Roles can be assumed by entity that you trust. That basically means when a user like you or me want to access AWS services, we have to create a IAM user that you can share your AWS console access such as the username, password, access key, secret key for them. But when AWS services wants to talk to each other, okay, wants to talk to each other, you use IAM roles and you attach it to that. So instead of having a access key and a secret key written into the services, for example, AWS Lambda wants to read data from S3. We have to create a connection between those two. Okay, one way is that you can use AWS access key and the secret key, put it inside the code, use the package for S3 and connect it and then do that. Or second way is you use IAM role. So it will create a automatic connection, or it will give the permission to AWS Lambda to read data from Amazon S3. Okay, so for that you will have to now next thing is what we are going to do is we are going to read data from Amazon S3 and do some cleansing to that particular data. Okay, and in order to do that we have to create a role. What we will do, AWS service use case is our AWS Lambda. Okay, simple. I come create a role, AWS service Lambda. I click on to the next, and now I will search for AWS Lambda basic execution role. Okay, this provides simple execution access onto AWS Lambda. So I'll click onto this. I will click onto next. I'll click the role name YT data pipeline Lambda role dev. Okay, this is the you can give the same name also. This is not universally unique. You can give the same name. I will click onto the create role. Okay, once this role is created, I will go to, let's say, Lambda role. Okay, this is my role. You can search it. So basic execution role is given, but we want to also give access to AWS S3. Now, one way you can do that is you can just go here and click on to add permission, attach policy, and give either full admin access, or I can give S3 full access also. But usually on cloud, you follow the principle of least privilege access. That means you only give access to the services that they need. Okay, you don't have to give all of the accesses right now. So based on the use case, you only give the access. So what we will do, you will click on to add permission and click on to the create inline policy. Okay, here you can click onto the JSON and give access this way. Okay, effect allow action, I want to give this access. So S3 get object, yeah, get object, comma, I'm just showing you for this one, S3 put object, comma, S3 list bucket. Okay, we want to give these three action, put object list bucket to the resources. Okay, and you write resources like this. So ARN, you can get it from here itself. I think if you go to S3, Oh, I think bronze. Okay, can't copy URL action copy. Is there any ARN to copy info? Okay, let it be. You can just write ARN colon AWS colon S3 triple colon. Then you write the bucket name YT. Okay, slash star. Okay, comma. You do the same but without star, and it will also need access to silver, so I will also do silver here, and same silver without the star. So what we are doing is that uh comma, let me remove the comma from here. So what we are doing is that you can I think format this somewhere. There's no formatting option. Okay, so what we are doing is that we are giving action. Okay, action is basically whatever action this lambda can take on S3, like I'm giving access to S3 get object, put object, and list bucket to only these buckets, not all of the S3 bucket, only these four buckets. Okay, the all of the subfolders and the main folder access. This is fine. So this is how you can give access to AWS S3. Okay, what I will do next, I will give S3 lambda YT pipeline policy, and I will click onto the create policy. Okay, so now Lambda can access specific buckets and the basic AWS Lambda execution role. This is done. So now we created the AWS IAM role. What we will do, we will go to Lambda, copy, open it onto the next tab. Okay, now let's look at what AWS Lambda is. So let's understand the AWS compute services. Okay, we have EC2 and the Lambda available. We already understood about the EC2. It is a virtual server in cloud. These are the different available, like general purpose, compute optimized, memory optimized, storage optimized. Pricings are on demand, reserved. You can have a spot instance available. You can have a saving plan. AMI is basically pre-configured server template. So let's say if you want to have a pre-web server installed onto your EC2, you can have a AMI created, like an image created for that, and security groups to protect the EC2 with the firewall. Okay. Then we have AWS Lambda. AWS Lambda is a serverless compute. It runs code without managing servers. Here you have to manage a little bit of server. You don't have to manage anything here. It is event driven, so you can trigger AWS Lambda with S3, API gateway, SQS, or any external trigger. You only pay for the compute the amount of time you consume. It supports Python, Node.js, Java, Go, Net, Ruby. Maximum 50 minutes of execution and 10 GB memory available. Layers for usable code and dependency, concurrency control, ideal for microservices, data processing, and automation. Let's look at the UI side. Okay, so go to the AWS Lambda here, here itself. Okay, this you will see. Again, I have all of these available, but in your case, you will not see anything. You will go to the dashboard. All you have to do is click onto the. Let's wait for this. Create function. Okay, you can author from scratch. You can use the existing blueprint, or you can use a container image. I'll go to author from scratch. Give the name as YT data pipeline JSON to Parquet dev. Runtime, you will select, let's say, Python 3.11. Okay, this is fine. Click onto the change default execution role and use another role. We created our own role here, which was, if you go to the role, YT. This was the role that we created, YT data pipeline lambda role. This is the role that you have to select. Okay, and then you click on the create information. I'll close this. Okay, so now we created a simple lambda. Okay, this is the UI. What you will see here, the function overview is a diagram or the template. You can also look at the backend of it. This is the diagram layer of it. You can add a trigger also. So as we saw here, you can use what is that, event driven, like you can add a trigger from S3, API gateway, or SQL. So for example, whenever any file is uploaded onto the Amazon S3, this lambda function code should run. Okay, this is sort of like the event available. Like you can have a API gateway, Alexa, you can have IoT, SNS, SQS, all of the different things are available here. mainly it is fine, all of this. So we have a code here available, which is like a VS code. We have a testing for that. You can monitor it, how it is using. You can configure some settings here, then alias and versioning. Okay, we'll go to the code, and we will put the code here, JSON to Parquet. Now this code we have written in our previous version. Now there are two ways. Again, in the world of AI, no one writes code anymore. Usually you can go to ChatGPT and you can tell, okay, I have my data available onto, let's say, this S3 bucket. I want to read this data and convert that data into the Parquet format. Okay, so sort of like I can do that. Uh, okay, can you write Lambda script to convert this data from uh, location above to into the silver bucket? Okay, I'll go to here. Let me just copy the bucket name we have here to silver bucket into Parquet file format. Okay, you can write, and this will give you the code into the Python. I forgot to say Python to it, but I think it will by default give me the Python code. What it will do, it will give you the entire code, and then you will be able to so it will give you the entire code. Okay, this will give you the source bucket. You can put the target bucket, Parquet compression. This will give you the entire code. So if you know the basics of Python, and if you're doing this project, if you're learning AWS, I expect that you know at least some Python language, so that you can understand all of these code. If you don't know, you can go to the Data Vidya. We have like detailed Python module available. You will have everything here, from installation to understanding about all of the basics of Python available. I teach you from basics. So if you want to learn Python, you can come here to the Data Vidya and learn it here itself. uh, I'll put the link in the description also, so you can come here and learn everything. But for this, what I want to do, I don't want to waste time writing all of this code right now. Okay, what we can do here is pretty simple. Yes, I have already written the code. I will explain you over the top, because these days we don't usually write code by ourselves. We can just use AI and put it over here. Okay, so this is the code I have written. I'll explain you the entire code, and what we will do, I will put the code here itself. Inside, you will find this entire repo onto the GitHub also. So inside this, we will create a folder. We will do Lambda. Okay, inside the Lambda, we will write, we'll create one more folder inside the Lambda also. JSON to Parquet, and the new Lambda function dot py. Okay, and I'll put it over here itself. Now what this code does is, first of all, it imports all of the packages like JSON, OS, login, date, time, URL, lib, Boto3 to work with AWS services, AWS Wrangler, and Pandas. There's a logger available if you want to log all of the messages inside. Then we have some configurations. Okay, so what first is, we store the silver bucket uh, name inside the environment. We will do that. Then we will also use the Glue database and Glue table. We will do that right now. We have to configure, because over here, what we will do, we will read data from the S3 bucket that we have. Okay, we will clean that data a little bit and store it into the Parquet file format as per the architecture. Okay, we want to read the raw data. We want to store this raw data into the Parquet file format. Okay, and to the store it over here and build a Glue catalog on top of it. Okay, so this is the action that we want to do. Uh, read from S3. Okay, process on Lambda. Now store on silver bucket. We store on silver bucket, but also store create glue db to store data there. Okay, so that we can also explore the raw data and how the raw data actually looks, and also explore on Athena. Now I know that, okay, learning AWS and also executing this is quite tricky, might be quite difficult, but again, while we are building a project, we have to take care of a lot of different things at the start only. That is the reason we plan things. Okay, so this is what we have in mind right now. We have done this. We are processing on Lambda, and then we will store it onto Silver bucket, and this is a script available for that. So we will put the Glue database table information, SNS topic also we will create that, and Silver path. Let's just understand what this code does from the higher level. Again, I expect you to know the basics of Python to understand this code. So whenever we upload any data onto the S3, or it will read the data from the S3, upload data, we will do the uploading of the data again. It will check if the event is empty or not. Okay, if the event is empty, it will not do anything. If event has some record, it will go one by one to the record. It will read all of the S3 data. Okay, based on it will extract the bucket name, and it will extract the key of it. Then it will read the JSON. Okay, we provide the bucket and the key. So there's a function available on the top that basically uses S3 client to get the data, uses body to decode, then load the JSON content. Once the JSON content are read, it will return the JSON content to the raw data. It will do the processing. It will normalize the JSON if it has the items. If it doesn't, it will just do the normalization. It will validate the category of the data. So there is a function available to validate the category. Basically, validate and clean the category of the data. So if there are any issues in that, so in this architecture, as we can see, we have Lambda function. Okay, now that Lambda function is converting our raw JSON data into transform Parquet format. So on the Lambda function, we will write transformation for JSON data, and on the Glue, we will use Apache Spark, PySpark to convert the CSV file, transform it, and put it onto the Silver. So we will use Lambda for the JSON one and Spark for the CSV, and convert both of them to the Parquet format and put it onto the S3 bucket. That will be we can see it on the AWS Glue. So we can do that easily. Okay, let's just start doing it. And now before we do that, right, like we configured AWS this Lambda role, we will have to create role for many different things. So first we will do the setup for the entire thing. Let's just do the entire setup for the access control, and then once the access controls are sorted, we will start executing all of the code level things. Okay, so we have already created this Lambda function yt Lambda onto the AWS Lambda. We might have to modify few things here also. So you can go into this, click onto this policy. Okay, the yt data pipeline, this policy, if you click onto this, you can edit it. And here I will paste this policy. Okay, uh, on top of this. So this is the policy we written for S3, where this is the policy that we wrote for S3. Now let me make sure the bucket names are proper. Okay, let me update this, update this, update this, and update this. This was silver, and this was silver 2. The same thing we did for Glue. Okay, so Lambda can get the Glue tables, get the databases, create tables, update tables, get the partition, create partition, batch, create partition. This SNS thing we will create and update it. Here we just have to put the account ID, and account ID you can copy it from the top right over here, you can see, and I can just click onto the copy account ID, paste it here. Okay, this entire thing you can of course get it from the GitHub. US is this resource AI and YT data pipeline. This is fine. We can update it afterwards when we create this. And Athena also we have to give access to query execution result and the starting the query. Okay, update this, save the changes, the access we gave, so that we can always use this. Now we also have to create the Glue execution rule, just like the Lambda. It can access S3. We also need Glue to access S3. So go to the roles, click onto the create role, and over here instead of Lambda, now we will select Glue. Click onto that. Go next, and here we will search for AWS Glue service role. Select that, go to the next, give the role name as YT data pipeline glue role dev, uh, create the role. Okay, and then you can open the same role here, YT data pipeline glue dev role. We will also add some inline policy, the same policy we had, but this policy we will have it for this, uh, like the way S3 could access, no, the Lambda could access S3 and glue. We also need, based on the architecture, we also need our glue, okay, to access S3 bucket over here, okay, and also the glue catalog and all of the other thing. So we also need to give the same set of permission. So add a permission, attach policy, no, not attach policy, add permission, create inline policy, and I will paste the JSON version here. Okay, this gives access to S3 and the resources we will have to update. So I will update the bronze bucket name. Okay, I will update my based on that you also have to update your silver. I will update my gold bucket, and I will update my script bucket so that it can access everything. So this is done, all of this is done. Now we can do next and create policy, and the policy name we will give it as YT data pipeline glue access, something like this, and create policy. Okay, so glue is done also. So now we have done two things. We gave AWS Lambda access to S3 and the glue catalog also, and we gave AWS glue to access to S3. Okay, so now it can do access the data from S3. There was one thing we did is like we created SNS, the simple notification service. We talked about this whenever we want to send notification to email or mobile number, we can send notification based on the quality check that we did here onto this, right? There's a data quality check and SNS failure notification we want to send if there are any failure. So we want to also do that. So just search SNS. All we are doing is just managing the access and policy right now, and then we will start writing the code. Okay, over here you can just on the left side, this is simple notification service, publisher subscriber messaging for microservices and serverless application. Okay, so SNS is usually used for that, like when you want to send a notification to different devices and location based on some action has occurred, you can do that. So we'll go to dashboard, click on the topic. On the left you will do create topic. We have FIFO and the standard. We will keep the standard also, best for messaging ordering at least once message delivery, and subscription protocol SQS. So first out is basically whatever message that goes first will always go out. So if you need that kind of requirement, you can always go for that. But standard is simple. Uh, just give the name as YT data pipeline alerts dev. Display name, it's optional, you don't need anything else, and just click onto the create topic. My topic is created. Now you have the topic is created, right? But we have to also subscribe to it in order to receive the notification. So there is a button over here, click on the create subscription. Now there are different ways you can subscribe. What we will need is email address. Okay, I want to get all of this information on my email, and I will just write my email, Darshil, this is my email address, and I will click onto the create subscription. Okay, now if you go to your email, you will receive message from the notification over here. Okay, so if you go to your email, this is my email, and I will receive the notification from subscription. I'll click on a confirm subscription. My subscription has been confirmed. If I close this, now I will start receiving all of the messages related to this, whatever happens, right? Make sure you copy this ARN and store it here, SNS ARN, and we'll paste it here so that we can use it afterwards. Now, I think onto our glue, not on the glue. I think onto our, if I go to Lambda role, let me just check that. Okay, Lambda role dev here. Just want to confirm this. Here we had SNS, right? Blue access SNS, right? So we have SNS available here. We will have to update this SNS with this one, SNS ARN. Okay, this one. And so what you have to do, you have to go to AWS Lambda YT pipeline policy. Okay, inside this role YT data pipeline Lambda role dev. Once you do that, go here and edit the SNS resource ARN over here to the SNS policy that we created, so that we give access to the right SNS that we created. Okay, so I think this part is done. Sort of like what we did, we set up the two Lambda role and added the custom permission, and we created notification service and subscribe to the email. So we did that. Now, in order to over here, right, in order to have this both of the things and write data and create a glue catalog, we will need a database, right? Because glue catalog stores data into the database tables, right? Now our setup now our basic setup is done. We have our IAM policy that has AWS Lambda has access to S3 and Glue. We have Glue that has access to this. Okay, we also have our simple notification service ready. Okay, so our components are ready. Now we have to start executing other things. Now, before we do that, let's spend some time on understanding theory. Okay, it's important that you understand what we just did. So I think we already understood about the AC2 and Lambda. Okay, there is also AWS Glue and EMR. So let's try to understand what that is. Okay, so AWS Glue is fully managed serverless ETL service. Okay, Glue data catalog, centralized repository, centralized metadata repository. So AWS Glue is usually used for ETL, but it is serverless. Just like EC2, we saw it is a virtual server in cloud where you can host your information, website, and every other thing. In AWS Lambda is a serverless compute service where we can write our Python code, any code, and it runs onto a trigger basis or the uh, as per your need. Okay, so this is ideal. Okay, this is serverless, has a limited capability but used to run the code without managing servers. This is where you have to manage a little bit of server. The same concept goes with the Apache Spark, which is where AWS Glue and the EMR comes. AWS Glue used for writing ETL jobs for Apache Spark or Python shell. Okay, so it is fully managed serverless ETL service. It has a data catalog, right? So it is about data of your data. That means it stores the information about your data, such as how many columns it has, what are the data types, the size of it, number of rows, all of the information about your data it will store. You will understand when we do that. Okay, then there is a crawler. Okay, what it does, it goes to your S3 file. Okay, it reads all of the information from the data so that you can start writing SQL queries on top of it. So it will auto discover schema from S3, JDBC, or any of the sources, and it will pull all of the information. Again, we will understand when we do the hands-on. Then we have the ETL job. You can write it in PySpark or Python shell. Job bookmarking for incremental processing. Dynamic Frame API extends the Apache Spark data frames. It also supports Parquet, JSON, CSV, ORC, Avro, integrates with Athena, Redshift, S3, and all of the other services. So AWS Glue is a serverless ETL service for Apache Spark. Then we have the EMR. Okay, this is the managed big data platform for Hadoop, Spark, Hive, Presto. This is usually used for processing very large scale of the data. Right now, that is we are using AWS Glue because we have the limited data. But EMR is used for processing very large scale of the data. We have the auto scaling cluster with the spot instance. You can have a spot instance available. A spot instance is basically if you want to, get AWS instance for minimum amount of time for a lower cost, for let's say 2 to 3 minutes. Usually when you do the standard, it will run the instance and it can run up to the longer period of time as whenever you need. Spot instance are usually available for small period of time, let's say the 10 minutes, 20 minutes, and there is a bidding happens also. We don't want to go into depth, but it's just a limited time instance available for your support. So we have the EMR on EC2, EMR on EKS, or EMR serverless. We have three things available. Either you can run EMR on EC2, that will automatically or install all of the Hadoop Spark into the cluster. So that will be the worker node and the leader node that will manage it. You can also run it on EKS, which is a Kubernetes service, and EMR serverless is also available. You can use a notebook for exploration. There are like Zeppelin notebooks available, Jupyter notebook available. You can use that. It also directs. It also has the direct access to HDFS. Hardly anyone uses it. Cost effective for large scale batch processing. Ideal when you need full stack Spark application. Okay. So again, understood AWS, EMR, and Glue. Let's spend time on Glue now and understand. So on to the AWS, just write Glue and open it onto the new tab. Okay. Mm, let's wait. Uh, so this is what the Glue console looks like. Earlier the console UI was different. Now it is a new UI. Over here, what do we have, right? Getting started, ETL jobs, right? If you want to create ETL jobs here, you can create it onto the script level, or you can use notebook. You can use also visual edit. Then we have the catalog tables available that we were talking here. Let me just get this. So again, we saw that it is a data catalog. Okay, it stores the information about your data. So as you can see, all of these are catalogs. I'll just show you one about from my previous project. So it stores the schema information about the table, like it has column name, date type, data type, partition also if it has the partition, indexes. All of these information are stored inside the catalog, right? All of the information are the catalog, and the data is coming from the S3. We will do this. Then you can also create connection with the external sources if you want to do that. Workflow orchestration if you want to orchestrate the entire system. This is the detailed data catalog. As you can see, this is the catalog available about everything. So there's a COVID-19 catalog. You will see uh, all of the table inside the COVID-19 we had. Like if I open this, I think we just opened this. So again, same column name and everything is available. We have the databases. Inside the databases we have the tables available. Okay. Then schema registry, we have connections we have. And the important thing we need to understand is the crawler. Okay, this is a crawler available that we will run on top of our files. So these things are available. These are the legacy pages, and this is for the data integration and ETL jobs that we will use. So this is the same overview, but this is just the in detail. So this is the UI of the Glue. What we want to do is we want to create a databases for our three section, which is what we learn here. One for the bronze, second for the silver, and for the gold. So any data that we crawl from here, we want to store it, that information, onto the that particular database. So go here onto the databases, click onto the add database, and let's just give YT pipeline bronze dev. Okay. And description if you want, you can just put it YT pipeline raw data, and click onto the create database. So one database is created. We will perform the same action for the silver also. So I'll put the silver here, and YouTube. This will be our cleanse data. Okay, and the same for a gold one. So I'll put here. I'll put this analytics aggregation. So we have bronze, silver, and gold available. The databases are available. Okay. Now in this example, again, we had in our Kaggle data, okay, we have JSON data available and the CSV data available. Now you can always run a crawler on top of the CSV data, but sometimes JSON data breaks because of the complexity of the file available. If it is a simple JSON data, Glue crawler might be able to crawl it, and you will be able to run SQL query. Sometimes if the it is some nested JSON available like this, it might not be able to do that, but we will try on our end. Okay, and let's just see how it goes. So what do we have to do? We have to run the crawler. Okay, crawler is basically, it will go onto the S3 files. It will read all of the schema details and put that onto the AWS Glue catalog. So I will click onto the create crawler, and I will give the name as YT data pipeline bronze crawler dev. Okay, click on to the next. Now we have to tell crawler that where is our data located. So we have to add a data source for that. So click on to the add data source. This data source is our S3. Again, you have a lot of options available here. You can get data from my RDBMS, Redshift, Iceberg, Hoodie tables. We'll just go for the S3. Okay, we don't need any connection in this account. I want to find the data. You can click onto the browse S3. The data is available onto our here this location YT data pipeline bronze. So I will just put that bucket, click onto this bucket, and you have to go till this level, right? I want to get crawl data from all of these folders with these folder partition. So I will go till here. I will just select raw statistics. Make sure you select till the raw statistics and choose. Okay, this is done, and add S3. Nothing else. Again, I can add the data, browse, same, and till the raw statistics reference data. This is our JSON data available. Okay, and I will add the data here also. Okay, so I have added both CSV and the JSON. I will go click next. Now we have to choose the IAM. We have already created our IAM over here. As you can see, this is Lambda one. Wait, I think yeah. So this role we created, YT data pipeline glue dev role, that we have to find here. Okay, this is it. If not, you can always refresh it. Everything else is fine. Click on to the next. Choose the database. In this, again, we are doing this for the bronze. So make sure you select the bronze database. If you want to add a prefix, you can add it. This is on demand. Click on to the next. Create the crawler. Okay, crawler has created. You can run this crawler by clicking over here. Just run the crawler. The crawler will start running. Created successfully. If you see, this is running over here. Crawler runs are being run. So it will take 1 minute to run the crawler. Okay. After the crawler runs, you will see the tables created into a database. So if I go to tables here, open it onto the new tab. Uh, Catalog is fine. Choose the database here as a bronze dev. Okay, right now no tables are available because crawler is crawling the entire data available on S3. Once it crawls, it will automatically create the table, and then we will be able to write SQL queries on top of it. Okay, till this till it is happening, let's move forward with our theories and try to understand the Athena part, right? Because once the crawler crawls our data, okay, how do we query it? And this is where the Amazon Athena querying and catalog service, right? We Amazon Athena comes. It is a serverless interactive query service. Okay, it is a serverless interactive query service, standard SQL on S3 data. So usually when we use relational databases, what we do is inside the database, right, we create tables and we physically store all of these data in the relational database. The data is present there. But here Amazon Athena is just the interactive query, ad hoc query interface. Okay, so it does not own any data. What it does, it uses Glue catalog that has the information about the data such as table name, schema, and all of that information to run SQL queries on top of the files that we uploaded onto the S3 bucket. So it is not storing any data inside the Athena. All it is doing is just running a query layer on top of the files. This is the power. So it you pay per the query that the data it scans. It supports Parquet, ORC, JSON, CSV. It uses Glue catalog as a meta store. CTAS for ETL. Okay, you can write ETL query and data transformation also. Maybe when we do the Athena, you will understand. Then there is Redshift Spectrum also. Okay, so Redshift is a data warehouse that we already saw previously. I think we are yet to touch the database module. We skipped it because to understand the other services. But Redshift is a data warehouse available on AWS. Okay, it's a OLAP based. If you don't know what OLAP and OLTP, I have a data engineering masterclass available on my YouTube channel also. If you go here, this masterclass is available. You can where is that? Yeah, 3 hours masterclass is available. Watch this and you will clear most of the fundamental concept of data engineering. Okay, so yeah, it is an OLAP based data warehouse. It is basically used for querying the data onto the Redshift cluster. It doesn't need data loading. You can use the standard SQL, and it is cost effective for cold and archive data. We don't want to touch Redshift right now. We have a glue data catalog that we already understood, right? Centralized metadata stores. It has tables, schemas, and partition shared across Athena, Redshift, EMR. Cross auto updates the schema, Hive compatible metastore, version table for definition. So data catalog we understood, Athena we understood. Let's look at our crawler. It is completed. It says table changes, 2 table changes, 20 partition change. Okay. If I go here and if I refresh, this is my tables, right? That we opened. You will see two tables are available. One is the CSV one and second is the CSV JSON one. Okay. Now I can query this data onto Amazon Athena. You can write Athena on top, open it in new tab. Okay. Here, click onto the query data in Athena console. Click onto the launch query editor. First, before you run the query, you will have to set up a result location. So on here, click on the query setting. Okay. And you have to, you might not have this, I have it already, but location of the query result, you will have to select any S3 bucket for that. So either you can create any simple S3 bucket for like that, let's say something like go to S3, click onto the create bucket and write something YT data pipeline uh, glue Athena query result. Okay, we'll do this, and everything else is fine. Click on to choose bucket. Okay, you can use this bucket now inside the Athena. Browse S3, click on to this, select this bucket, choose and save. So all of the result that you execute will be stored here. Now this is what the Athena console looks like. Catalog is this, and you can select the database as bronze, and you will see raw statistics and the reference data is created. If I click onto the preview by clicking here, you will see all of the data are available as it is. Okay, these are the some new lines available. Also some this is the raw data, right? It is not properly clean data, so you will see a lot of issues in this data, but we are able to at least look at the data from Athena. So if you want to understand what the data looks like, does the data have, you can always check here. You can also go to the catalog here, bronze, and click onto the this. You will understand about this also. Raw statistics, database name is this, CSV location is this. We have this columns, these are the columns available, and this is the partition available. Click onto the partition, you will see partitions are based on the region, so our files are divided based on the partition. That is how we have created our structure also. Okay, and you can view the files, you can view the properties. Okay, then we have the indexes available, so it is index based on the region key that we have. And column statistics, right now we don't have anything. Okay, so this is the catalog, the data about our data. Okay, it stores the information about our data. This is the advanced properties, how it actually created this table. So you can see the record count, uh, crawler information, size of the key, skipping the first header count. All of these different information are available here. Okay, so I'm able to query this CSV one. Let's try to query this JSON one, and you will see we get some error. The error is because it is a JSON nested data, so we are not able to actually read it on Athena, and it might have some issue in the data file also, so we are not able to read it. Totally okay. We don't want to worry about that. When we transform our data from JSON to Parquet, we will be able to read it. Okay, so you can write some queries here also if you want analytics query to get information such as query like this. Select region and aggregate by count, and then from raw statistics, group by region, order by count, and you will see the highest videos are in like CA region, then USD, like that. We're able to get the information that CA has the highest video count. Like that, you can also run query like this. This is giving you information on inside the region of US, and you are able to see, wait, it's not capital, it's small US. Wait, yeah. And now here you can see that, okay, this is the video ID. Okay, it looks like this. Trending date is quite weird, as you can see, right? It is like 17, 14, 11. This is into like YY, DD or MM format. This is like year, this is month, not month, the day and month. So we also want to standardize this when we actually convert our raw data into the silver data. When we transform our data, we want to make sure that trending date is in proper format. Okay, then this is fine. I think this is fine, this is fine. So just by looking at the raw data, we can understand that, okay, this data has a lot of issues that we need to fix, right, before we move forward. So that will happen into our silver. Okay, so this is done. Let me go here. Uh, Over here, we were able to, what we did, right? We are getting this data. Okay, we are yet to write the transformation block for this. But what we did, we ran the glue crawler. Okay, we also have the archive that automatically goes here, and now we are able to read our data onto the Amazon Athena. Okay, the raw one for the raw. Now let's start writing the data for this also. So let's get the data first here, then we will move forward. Okay, let's just get all of the raw JSON data also added to this, so that we have the consistent data coming also. Okay, so we convert that into Parquet, and then we'll write this. So we will be writing our extract data pipeline from the YouTube data API. So we did everything for the static data. Now let's do it for our API. Okay, so let's go to AWS Lambda. And on the Lambda, we will create a function, and author from scratch, we will give YT data pipeline ingestion dev. Okay, YT data pipeline YouTube ingestion dev. Everything else is same. Click onto the execution role, select the Lambda role that we created. Where is that? YT data pipeline Lambda dev role, create a function. Okay, now we have to write a code again. There are multiple ways we can do this. One, we can write code over by self, or you can directly use chat gpt or Claude to generate the code. I've already done this project previously, so I have the code available. So what I will do, again, I expect you guys to know basics of SQL and Python, because this is quite advanced project. So we are not going to go deep dive into the Python. If you want to learn Python, again, we have a dedicated section available on datavidya.com/learn. You will learn everything about the Python, from strings, number, variables. We also have a project available on Spotify data pipeline. So if you are very learning Python from scratch, this is the best resource you can go to and learn about the Python and everything we have. Like, we also have advanced Python available and everything with the editorial and the video, so it will help you to learn faster. We have learn section for fundamentals SQL. We also have the practice platform for coding, so you can also code here for the interviews. But this is something else, right? Over here, for ingestion of the data. Okay, go to the new folder in your VS Code and just write lambdas. We will lambdas. Okay, we will put all of our code here. So first is YouTube API ingestion. Okay, and here we will write lambda function. Usually the lambda function name, the file of the lambda function should be always lambda function.py, because let me, oh shit, this lambda function, I'll have to recreate this and delete this one. The reason for that is this ingestion one. I selected the Node.js. We had to select the Python. Okay, so let me delete this, confirm. If you have got that error, then make sure you correct it also. So this Python 311, use role, I'll choose lambda role and click onto the create function. Okay, this is done. okay, here. Okay, so the lambda handler. Okay, usually this is the lambda function dot py. The same, you usually keep this only name, and the lambda handler is the start of the execution of the lambda. So whatever you do, it will start the execution from here itself. So let me paste the code to extract the data from API. I'll explain you this entire code. If you want to understand the code, it's pretty simple. All you do is copy the code. Ask the ChatGPT, can you help me understand this code line by line? Okay, and put this. If you know Python, you will be able to understand just by reading it. If you don't know, this is the best way, because if again, we'll be writing a lot of code, so it doesn't make sense to explain each and every code one by one. So you can go here and this will help you understand entire thing one by one, but I'll explain you also from the top. First, we import the important package as a JSON, OS login, and all of the other things. Boto3 to work with the AWS APIs. Then we import two clients, one for the S3 client, so boto3.client S3. Second is SNS client, boto3 client.sns. Then we import configuration such as YouTube API key that we will store into our environment variable, S3 bucket, the bronze bucket name, where we will put the raw data. We have the regions that we want to work with. Okay, environment, then we have API of the Google, and the max result that we want to get. So the function starts here. Okay, simple. You define all of the dates. You go from the regions, all of the regions that you have, that you want to pull the data from, just like our raw data, the static data that we have. Then it will do some processing of this. It will go to the fetch trending videos. It will hit the URL, it will get the result. Okay, it will open it and it will put the result back here, trending data. Did we get any data or not? If we got, it will put that onto the dictionary. Okay, and it will write that data onto the S3 bucket as a JSON file. After this, these are just exception. If any of the issue occurs, it will raise the exception here. After that, we want to fetch the category of the data. So there is a function created fetch category. Again, it will hit the URL of the video categories. It will send the region code for each of it based on region we have available. It will request that once if the data is available, it will return the data. It will write that category data again. Okay, and at the end we'll just summarize the result and send the SNS notification if there's any failure. Again, you can go through this code entirely. Don't want to spend the entire time explaining you the code because quite long code. What we will do, we will just do the basic setup required for this code to move forward. So let me go to Lambda. Okay, first go to configuration. Here, edit the configuration and increase the memory to 512, storage to 1024 right now, and the timeout, make sure timeout is 5 minutes, so that at least Lambda runs for the 5 minutes. Okay, then after that, click on to the environment variables inside the configuration. One is you need first thing is UPI, not UPI, YouTube API key, and click onto the value you can get from console. Get YouTube API key. Just go online. You will see this UPI data API account. So you need Google account for that. You can go to the Google developer account over here. Right click. This will open the console, and it might ask you to enable the YouTube project API, or if it is YouTube data API 3, click onto this below. You might have to enable it if you are doing it for the first time. I've already done that. Then it has the credentials here. Okay, let me just reset this. Okay, so I have the credential available. In your case, you can just see, if I do the show key, you will see this is the key available. I will deactivate this key after this video, but this is the key available. If you want, you can just click on the create credential API key. Just give the name over here, YouTube API version 3. Okay, and you can have no restriction, and just click on to the create. and it will create for you. Okay, so let me just put my API key, copy this, and you can put your API key here. Okay, so I put my API key. After that, you have to put S3 bucket bronze. So we can go to the bucket. Okay, YT. Oh, sorry, we can just copy it from here. Oh, I had a typo here. That's why. Okay, bronze. Forget it. I'll put it here, and SNS alert topic ARN. Okay, we also have this. Okay, and YouTube regions. Now, if you want to process all of the regions, you can get data from all of the regions. If you just want to get data from selected regions, you can also do that. So let's just see. Okay, let me just see the code. Okay, YouTube regions, it is getting from split. Okay, let's just put a few regions here. US, GB, CA in. Okay, the environment variables are set, and then let me just paste the code here. Pasting the code. Click on to the deploy. Okay, so we are getting all of this information from here. Max result 5. Now we can test this. So click onto the test. Click onto the new test event over here. Okay, give the name YT bronze bronze test. Okay, and save this and invoke it. Okay, if you pull this again, the UI is quite uh, chaotic. You will see there is a success status message for me for this and no failure. So it actually wrote something. If I go here onto my this bucket with the typo, okay, it wrote data into the capital letters. Okay, so I think we will have to change this. So GB India and US. What I will do, I will delete this first. I'll delete it. Okay, go to my this configuration, or wait, we can just do on the right level itself. We post this when we write region. Let's find region. Okay, so there is upper case going on here. Okay, then region before we write. Okay, S3 key. Okay, over here region US, we can just do lower. It's like this, lower. Okay, and I'll deploy this. Oh, is there any other region? This is fine. Also for category also dot lower. Okay, I will deploy this and I will test this. Okay, this is done and I close. Now I refresh. Okay, it is still writing it in the capital letter. We don't want this. We need to write this inside this itself, not into the new folder. Okay, let's see. uh, let's just try to remove upper from here itself at this point only. We will remove upper. Okay, let me delete this capital. Delete. Okay, deployed. Let's test it. It's running. Oh, success is still getting the capital one. Okay, let me just delete this again. Uh, yeah. Uh, let's see. Okay, from the top. I think this is very small. I'm not able to see. Okay, the use YouTube regions get these. Okay. If we change environment variable, let's say we are getting regions here, and after the regions, we extract regions somewhere here. Okay, this is upper, so we'll just do lower to this. I think this should fix that issue, because if we are doing lower at this level, that will fix it. It is deploying. Let's test it. The output should come into the lower characters. Yeah, now it is coming to the lower character. So now if you go to raw statistics CA, you will see JSON is available here. And if I download this JSON and if I open this, you will see the same information. I mean, again, the data that was coming in 2014 or 17 was different, and the data that YouTube API returns is different. So we will have to tackle that that way. So it has so see so this data has all of the information such as e tag, ID, publish, channel ID, title, description, thumbnail information. All of the informations are available here only. So we will be able to use this data to write our transformation. Okay, so our ingestion is working now. So now we got our YouTube data API onto the bronze and also the Kaggle dataset. We will not touch the Kaggle dataset. We will work with the YouTube data API. All of the JSON data we will now transform that AWS Lambda raw data into the transform Parquet format. Okay, so let's just do that on AWS Lambda. We have already created the function which is JSON to Parquet dev. Okay, let me just we can just paste the code also for that. So in our Lambda, create new folder, JSON to Parquet. Okay, and here uh, we can paste the code, new file, lambda function dot py. Okay, and again it is same. Okay, JSON reference data to silver Parquet data triggered by S3 event when the new JSON lands into the bronze bucket under the reference data prefix. Improves overall original data, so it does the validation, deduplication, proper error handling, idempotent writes, structure logging. We need S3 bucket of the silver, blue database name, table reference, and SNS ARN. Does the same. We read the data from environment, have the two objects created based on the event that comes on the S3. So anytime any raw data from the API comes to the S3, it will read that event. It will read the JSON from S3. So there is a code like from get object, get the body, and it will return the S3. Okay, it will check if it is items available, then it will normalize based on that. If not, it will directly convert that into the data frame. Then it will validate the category. So there are some rules added. So value error if there is no category found. It will check the title if there are no title found. If it will check if there are any missing columns available. It will avoid. It will drop the duplicates of the data here. It will add the ingestion timestamp and the source file key. Region unknown if there are no regions available. It will loop that and add the region according to that, and then it will write the Parquet file at the end. Okay, Out of this, if there any error occurs, it will send the send alert to the white data pipeline, and it will send the message. So we will get the SNS topic here, right? SNS client dot publish topic, subject, and the message. Simple, right? All we are doing is just reading the JSON data, processing it little bit, okay, cleansing it, removing the duplicates, making sure it is in the proper format, and then processing that data onto the silver bucket. Let me just copy this and paste it over here. For this also, we will have to configure our Lambda function properly. So you can go to configuration of this, make sure you edit memory to, let's say, 512.1024, 5 minutes timeout, and save. Environment variables, click on to edit. We will have S3 silver bucket added. So S3 silver bucket, you can copy the S3 silver bucket. Where is that? From here. After that, we have to add glue db URL. We can get it from glue itself. Databases, we can store that this also. Glue bronze, glue gold, glue silver. Okay. So we need silver database added to the environment variable of Lambda, and SNS alert topic ARN. This we can use this to copy and paste here and save it. Okay, so environment variables are added. You can do save. Now we want to run this Lambda based on the trigger. The trigger we want is, I want to add a trigger onto S3. Okay, the bucket name we have this bronze. Okay, I made a typo there. This is the bucket. Okay, and event type all event created. Prefix, you can have this only the category data that we are getting. uh, Dot JSON, I acknowledge this and add. Okay, so what I did, I added a trigger onto the S3 bucket of the raw statistics reference. Okay, so any data like CA, if I go any data category data that comes here, we will be able to uh, any data that comes here, okay, it will automatically trigger this Lambda function, okay, that will convert this JSON data into the Parquet format. Let me open that also. Bucket silver is this. Okay, so it will process this JSON data and put that onto the silver bucket after processing it. If you want to test it, all you have to do is go to the previous Lambda function, which was the our API that is ingesting data from the YouTube. Test this. Okay, so I will test it. Okay, it is successful, so it added some data. Now we will wait if any objects are written here. Okay, so it should automatically trigger this Parquet to dev. If you want, you can go to the monitor and click onto the view CloudWatch. It will show the logs of how our Lambda is running, and we'll be able to understand if we get anything or not. Okay, so right now it ran. I think there are no logs added yet. So let's just refresh this. If there are any runs or not. I think let me go back. No logs yet. It didn't run maybe. Okay, might be some issue. Let me check the trigger again. For YouTube, raw statistics data, this is fine. Is complex object created. So this should run. Let me run this one more time. This lambda function of the ingestion test. Test one more time. This is running. Okay, this ran. Let's see the logs. If there any, okay, so there is one log. So it started running. I think did we deploy this code? Let me wait. Okay, this is undeployed. Okay, my bad. We did not deploy this code, so we have to deploy this code first. JSON to Parquet dev. Okay, and also we are using most likely pandas here somewhere. Okay, we are using pandas. So for that we will have to add a layer. So click onto the edit below, add layer. Okay, and there will be AWS SDK pandas. We have lambda SDK pandas for 311, 38, 39, 310. Okay, 311 is here. Okay, so based on our Python version, this is my SDK. I will add and save this. Now I think it should work. So this is done. We have deployed our code. It was not deployed. Now if we do the test onto the YouTube ingestion, okay, if I go to the logs, there will be one more log. I think it will start. Found credentials and environment variable. So this is happening. Okay, it is running. I will see if any error comes. Okay, row shape return to silver. Okay, it wrote to silver and it ended. If I go to silver bucket and if I refresh this, okay, I have the YouTube reference data, this into the Parquet format available. Okay, so reference data is available now. Raw statistics reference data is available onto the Parquet. So this part of lambda to writing a Parquet is done. Okay, we are able to read the JSON data of the reference and we are able to write that data back to the Amazon Silver. So this is done. Now we will do the glue part. Okay, so wait, let me close these things, extra things. I have a lot of tabs front of me right now. So let me close them so that it's more easier. So we are able to do this much now. Okay, as you know, we are able to get the data from API. Automatically it lands the data on S3 and automatically it triggers the data onto the JSON and it runs the Parquet and stores the data onto the S3. We will do the glue crawler afterwards, but this is happening. Okay, we are able to do this. So amazing. If you reach to this section, good job. Let me just have water. We have long way to go yet. The reason it is taking time because uh, if I was just doing this project, I can finish this in maybe 1 to 2 hours, explain you everything on top. But we are also learning about AWS while we do this, right? We are also understanding about the services, what is happening, the UI, different errors and issues I'm trying to show you. So that is the reason it is taking some time. So just relax. If you want to take a break and then continue. Okay. But we'll move forward. If you have taken break, good. But let's move forward and let's try to write the glue job. Okay. Now, before we write a glue job, we want to also write this data quality function, right? Let's just check the data quality, right? Once you do this, do we get the data into the proper quality or not, so that we can receive the notification. So go back to the lambda function, click on the create lambda function. We can just finish the lambda part right now only. So put the data pipeline data quality dev, Python 311, execution role. We have YT data pipeline lambda, create the function. Okay. Uh, configuration, again, update the configuration first. Memory, you can keep 512, storage, 512 is fine, 1024 to be safe, timeout to 5 minutes. Environment variables, here we will need environment variables as just SNS ARN, okay, and you can copy this and paste this and save. This lambda is created. So we will write this lambda function code. uh okay, so this lambda is created, okay, for the transformation, and ingestion for the lambda is also created. Now we will write the transformation afterwards, okay, to check both of the Parquet files. But right now let's just go with the glue. I think that's because we can finish the entire this silver layer, so that we don't have to worry about all of the future things. Okay, so let's just go to the glue. So open the glue. Okay, this is a glue console. Go to the ETL jobs. Okay, and onto the ETL jobs, we click onto the script editor. Start script. We click onto the start of the fresh script and click onto the create. Now here we have to write a script. So let me just get the scripts also for this. So create a new folder here. We will do glue jobs, okay, and new file, bronze to silver, bronze to silver statistics.py, okay, and let me just get the code. Okay, so again, this code gets the bronze to silver statistics data, okay, reads the CSV JSON statistics from the bronze layer, applies schema enforcement, data cleansing, duplication, and cleans the Parquet to the silver layer. Again, this will do the data quality check, deduplication, parsing, handling both Kaggle CSV data and the live JSON data that we are getting, partition by the region and date, bookmarking incremental, and proper logging. We will put these job parameters while running. Basically, both database name from the bronze and this bronze database and table, silver bucket and database, and table path. Okay. So this Spark script, okay, it's a simple Python. Also, if you don't know Spark, I will highly encourage you uh, take a course. We have it available onto the Data Vidya. You go to Data Vidya / Python PySpark. You will learn about the PySpark also. We have like projects available onto the basic level projects available onto the PySpark also. This will teach you everything from basic about the PySpark, and long editorials about the architecture and everything is there. So if you want to go deep dive into PySpark, you can always come to the resources. But right now I'll explain you this code from the top, what it is. Okay, so this is a glue Spark. We import all of the glue related packages like Spark context, glue context, job, dynamic frame, and everything. These are data type included. These are the parameters that we will find. These are the start of the glue job that we have to define. All of the environment variables we are getting here. The simplest thing is simple. We are reading the data, so we read the all of the region that we have selected, CA, GB, US. Okay, we created a data frame of, basically we read the data from the table, okay, and then have our data source created. Then once we have our data source created, we convert that into the data frame, get the count of it, and start processing all of this data. Processing basically means convert the ID from video ID, make sure our the date time, I think the date format we had like MMDD, YYMMDD format. We convert that into the proper date time format. We alias some columns, we drop some columns. So this is basically columnar operation that we are doing. This is for the JSON file that we are getting. Else we do it for the CSV file that we have. Okay, so we have like two types of files. One is JSON and one is the CSV file. So if it has the title or title that this way, then it will process this way. Else it will just do the processing and change the data type. Then these are the data cleansing is happening. So we drop the null values, standardize the region codes to uppercase. I think it should be just lowercase. We don't want to go the uppercase. And then with column, pass the trending data from this format to the proper date format. We do that, fill the numeric value with the 0, add derived columns like ratio or something. Then we have engagement rate also. Okay, and then we add the processing metadata such as what was the time of processing, the job name, do the deep duplication of the data. So we use window function to deduplicate some data, do some data quality checks to make sure we don't have the null values into the columns, and filter some of the views that is less than 0, like views can't be negative. So all of these things, and then we write back to the silver. So all it is just a simple transformation script. Just go through it. No one writes code anymore. I just want to say tell you, this is the code that I've generated using Claude. If you want to understand, again, I'll create the video onto the AI using data engineering. You can easily do this. You don't have to write all of the code. You just have to define the context, and AI will generate all of the code for you. But you need to know, you need to understand the basics of coding in order to understand what this code is doing. But still, you can copy this code and paste it to AI, and it will give you a complete explanation of what it does onto the deep level. But if you know basics of Python or the Spark, you can easily understand all of this. Okay. And again, if you don't know, I highly encourage you to take any course available in the market. We also have a course available, but you can go with any of the resources that you like enough skill, because this project is again, we are doing a cloud project. So I expect you to know all of the basics of data engineering, at least Spark, Python, SQL, so that you can do this project. Okay, so this is done. What we will do, we will put this script to the glue only. So let me just come here, copy this and paste this. So the script is pasted here. We can change the job name. So give the job name as this YT data pipeline, bronze to silver dev. IAM role, we have already created the glue IAM role. This is YT data pipeline glue role dev. All of this is fine. GX1 worker, we don't want 10 workers, we just want 2. Other than that, advanced properties, we have to make sure we have things proper. So mm, YT diff script file name, this will put the script here. This is fine. Temporary location, we have it here. If you, I think it will automatically create. If it does not, you can just create a simple bucket and put it this way. Most likely it will create automatically. We just have to pass, I think, parameters, right? Job parameters over here. Okay, so make sure this is proper. If you make mistake here, it will break your glue script. So let's just write onto our information MD only. Okay, first is dash dash bronze database. Okay, and that is our this one. Okay, dash dash bronze table, and that we will have to uh, inside the bronze. This is raw statistics. This is a table name. So this is that. Then silver bucket. So bucket, we already have that. Okay, and then silver database. For database, okay, we have it here. Okay, and then we need silver table. We will give the name as clean statistics. Okay, so these are the parameters. The job expect here. If I go to glue, the where's the script? Okay, here. So these are the parameters is expect. The table information, database information, all of the other information that it will use to write the data, read the data, and update it. Okay, we have to enter it here in the same format. So I'll just copy this bronze database value as this. Okay, and then bronze table. Again, you can hard code all of these value inside the code itself, but it's a good practice to provide it on the parameter level, because you can always change the parameter as per your need instead of changing the entire code. Okay, and silver table. Okay, so this is done. Other than that, I think I'll just save this, and I think we can just run this script now. Okay, hopefully we don't face any error. If we do face any error, we will tackle that. Okay, you can go to runs. So it started running. We'll just wait for this to finish. It might take 1 to 2 minutes. Okay, let me just revise what we just did. So again, we have data that is being put here, Kaggle data that is being put here. Using YouTube API, we are getting both of the data for category and the statistics. We use AWS Lambda to convert the JSON data, but we are using AWS Glue to transform the both JSON and CSV data. This is just category data, and this is raw statistics data. Both of the data we are putting out over here, and then we will create a Glue catalog on top of both to see what is happening. Okay, so this is happening. Let's see the runs. Let's hope it doesn't fail. Most likely it shouldn't fail. Uh, if it fails, we'll just do Claude and see what is the issue. Most likely, if you face any issue, the issue will be on the parameter level. Code is running fine because I have tested this code. Uh, if you have to build this project from the scratch, it might take a week every day. If you set for 3 to 4 hours, you can do that. Using AI, you can finish this quite earlier if you give a proper context of what you want to do, and test the script, face errors, and keep fixing it. So it is possible. But this was the expanded version of our previous project. So in the previous project, it was quite simple. I already explained you. We were just using simple glue and lambda to just pass the data from 3 layers using Athena, and we were done. But now we have like upgraded the entire project with the actual YouTube API, added the Kaggle dataset, Amazon S3 glue crawler here, silver layer to transform glue into the parquet, then data quality gate, and all of these things are coming. Okay, so that is the reason this project is quite advanced. So I'm not going to onto the code level, but onto the higher execution level, how things are working overall. Okay, so it takes 2 minutes. I think it is running. I have a hard feeling that it will fail. Let's see. Uh, Fingers crossed. I'll just wait for this. If it fails, I'll see what is going on. If it doesn't, then we are good. If you're watching this video till here, do let me know if you reached to this part. Just write, I am running Glue, or I am running my first Glue job. I will know you reached to this section. And do let me know if you like this video or not. Make sure you hit that like button. And if you are someone who is interested in learning about data engineering, we have a complete platform also available for data engineers that is not about just learning. It will actually help you to prepare for the interviews. So we have editorials, but we have a coding platform like a lead code for data engineers where you can come practice PySpark, Python, all of the other things like Postgres, DBT. We also have this data modeling canvas where you can prepare data modeling rounds, architecture design. If you want to build architecture, you can also come and build here. You can also review your resume and get tested by AI. Okay. Let's see. It's still running. Oh, 3 minutes. It's taking long. But usually, when you run a glue script, what usually happens is the bootstrapping of the glue. Okay, because it is serverless, it actually has to run all of the server, and it have to invoke everything, the Spark cluster and everything in the backend. So it takes time, right? It is not going to be like a Python or pandas, pandas or the lambda script that it just gives you the result right away. It is going to take 3 to 8 minutes to run the entire thing. Okay, it is successful. Okay, awesome. Uh, okay, we'll go to the silver and we'll refresh this. We have statistics data available, all of the four regions, and the Parquet data available. Woohoo, good job. So if this is happening, right, we have crossed one barrier of the glue because most of you are going to stuck on the glue. And if you are able to do this, if you are able to see the things, see, it worked for me because everything was correct. I'll tell you again, I'll remind you that I have done this project previously. That is reason I'm able to do it properly and teach you this. I have to prepare the project. Okay, so our project is so we are able to get the Parquet data available for both of it, right? The reference data we had and the also the statistics, and also it is into the very clean format. As you can see, the raw data we had quite messy. YouTube data API is coming, the raw data is there from Kaggle, everything is just put into the folder, but this is quite clean. We have the one Parquet here and statistics Parquet here, simple, nothing messing it around. So this is fine, right? Our glue is running properly and we are able to get the data and we will be able to get the recent data. Oof. Now we can verify all of this data onto the Athena. So you can go here onto Athena, click onto the silver dev. Okay. We have clean reference data, clean statistics. Where did this come from? From the script itself. If I go back, if I show you the script over here, it writes data to the glue context. Okay, it creates the catalog information. Okay, so if we have the catalog, we can query that data onto the Athena. Okay, we have data onto S3, we have data available on, we have catalog available onto the glue catalog, so that we can use Athena to directly query it. So it writes data to S3. Okay, so it writes data to S3, but also writes data to the catalog. So we are able to directly query without running the crawler. So I can just do preview table for the statistics and you will see all of the data are available here properly. This is the cleaner version. And trending parsed. Okay, this is the parsed state. This state that we saw into the trending date, which was messy. Now we have proper date available also. So we process that. We also have this job name and the process add information available for the further tracking. Okay. The same for the reference data. We were not able to query the JSON file, but now we are able to query the JSON also because we converted that data onto the Parquet file format and both of the data are visible. Okay. This part, let me see. This part, uh, 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 fill color transparent. Okay, this part is done. Okay, this much part we have completed successfully. Let me just do this. We are able to do this, have a life cycle to Glacier, Lambda to this, Glue, ETL to this, catalog is registered automatically. Now we can start working on this, and at the end we will just automate the entire thing. Everything that we are doing individually, we will just do the entire thing together and we will have our final version available. So let's move forward and work on the data quality one that is pending. Uh, we already created the Lambda function for that. So let me just put the code here first. Data quality and new Python dq underscore lambda dot py. Okay. Now this data quality, okay, called by the step function. We will not call this. This is just we are putting it so that when we work on a step function, it will validate our data before allowing our data to send to the gold aggregation layer to make sure we have the row count, enough data available, null percentage, check how much null we have, schema validation, value range check. So we want to make sure, let's say views are not in the minus negative category or into like weird way. like 5.2 is not a view. Okay, freshness, how recent data is enough, right? So these are the custom logic as per the business requirement that we have to keep to make sure. Let's say we say like, okay, only data should pass if we have like 20,000 rows available, or it should not pass, or null percentage should be less than 2% only. So these are our own requirements based on the business, that does the data pass the quality check as per our standard. Okay. And the environment variable is just a silver bucket and the SNS topic. Pretty simple. For each of the data quality check, we just have a custom logic written. So we fetch the data from the database table, okay, and then we start querying the data and sending it to the different functions. So we will read the sample data from the file. We will check the row count. So there is a function available that will check the row length of the data, that will return the entire check if it passes or fails. And the same way it will do for the percentage, schema, value, freshness. Again, you can just go to the code. This is a simple Python code with if else statement and checking if the data makes sense or not. Okay. What we will do, we will go to the data quality pipeline. Okay. SNS topic is already configured here. We have to first paste the code here and make sure it is deployed. And after that, configuration, edit, and we have to add I think, I think this is fine. This SNS is here. What else do we need? I don't think we need to add S3 silver bucket. It will, wait, let me check the data. Okay, it is here. YT pipeline silver dev. Okay, so it is directly reading it from here only. Okay, and table clean statistics. Okay, so this is fine. I think this is the name of our also YT. So this is glue catalog we have, and clean statistics. Okay, this is fine. Okay, we don't have to do here anything here. So glue also, this is fine. General configuration is fine. So again, this is deployed. So we don't have to worry anything here. Okay, my voice is breaking. Let me just have some water. Okay. So our code is deployed. Okay, so where is that? Okay, so this much part is sort of done because this is handled inside the Lambda only. We can start working on the gold layer. So now we will do this. So now we will write AWS Glue aggregation ETL, and we will build the analytics layer. Same, we will have our data available onto the AWS S3 gold layer, and also automatically created catalog that can be easily queried by Amazon Athena. And at the end, you can basically orchestrate the entire thing using step functions. So we have two things to do. So let's get started. Let me open this glue jobs, new file, silver to silver to gold analytics.py. Okay. I'll just paste the code one by one so it's more easier to understand. First of all, we import all of the packages. So this result options, Spark context, glue context, job, dynamic frame, window function, and Spark SQL. Okay, this is what we will be doing inside this. So silver to gold, read the clean statistics and reference data from the silver. Okay, join them and produce the business level aggregation in gold layer. So gold layer are analytics, usually optimized for analytics, query, and Athena and QuickSight. Three tables we will produce: trending analytics, this is daily trending summaries per region; channel analytics, channel performance metrics; and category analytics, category level trends over time. These are the parameters we'll need: job name, silver database, gold bucket, and database. After that, we will read the this parameters that we submit. So this is how we read: get resolved option, system arc, and these are the argument that we want to read. Then we have to define the spark context, glue context, and start reading all of these argument into the proper variable. So we read, create the spark context, put that into the glue context, create the spark session, get the glue context inside the job, register our job, and set up the logger. And these are the variables that we will read from the parameter. After that, we will read the silver tables. Pretty simple. Put the logger information here, glue context, create dynamic frame from catalog, database, table, and transformation. Convert that into a data frame and log that information. And after that, we will read the reference data and category lookup. So silver data, reference data for the category columns we will read. Same, read from the catalog, check the category. It will check if the ID and title are matching, then it will change the alias of that. If not, it will change the alias to this way. So this was a fix that I had to add, because sometimes from the YouTube API, the category ID was not coming, and the title was coming into the different column name. So we added this small check here. It will check if the ID and the snip.title is like this in the column, then it will add the alias this way. If it is coming this way, then it will add alias this way. Else it will just log the warning. And if there are no category, then it will create the category. This was added just so that if the category is missing from it, then we will add this check. Okay. So this will always guarantee the category always exists, even if it is null. After that, we will create the three goal table. First goal table, trending analytics. This is pretty simple. We just do the group by region and trending. All of the core metrics we put here, add to the column, and then we write that to the S3 file and also the glue context. Pretty simple. This is a simple SQL operation. You can write it into the SQL also, but this is a simple Parse script. Get the data frame, group that, okay, add column. This is a path. Put that onto the S3, put that onto the glue catalog. Same goes for the channel analytics. Similar functions will be applied. Uh, a group by title and region, all of the metrics, average, sum, max, minimum, whatever it is. Uh, do the ranking, write that onto the S3 and catalog. Same goes with the third one, which is category analytics. So group by, partition this, write this, and at the end you commit it. So this is the entire silver to gold. We will do paste this code onto the glue ETL. So I think it is pretty simple. We should know that go to ETL jobs, script editor, create a script, paste this script. Okay. We will update our script name. Wait for this. The job name is this. Okay. Then we have to choose the IAM, which is glue YT data. This request worker. Let's go with 2. After that, we have to paste this one, which is the parameters that we need. One is dash dash silver. I think we already have this. Let's just go here and copy this from here. One is we need silver database. Second, we need gold bucket. PUCK. Okay, and gold database. Okay, so let's just, so it will read from silver database. Okay, we have, it will put data to the gold bucket, and gold database, it will create the table and the catalog. This is done. We will save. Let's hope we don't face any issue. We run this. This starts running. Now if it is successful, basically what will happen, okay, the data that is stored here onto the silver, it will read that, it will create that into the three different tables. It will put the those three different table information here also and the Google catalog. If this is successful, then we will be done with this and sort of done with this also. Okay, so let's just wait for this to finish, and if it is finishes, then all we will have to do is understand about the step function. So while this is running, okay, this will take some time. If it fails, we will tackle the issue, but if it is successful, then we are done. So we sort of done everything. I don't think anything else is remaining here. If it is, then we will check that, but I think most of the things are done. Let's continue with our theory, okay, till this is running. So I think we have completed this. Let's understand about the QuickSight and Kinesis till our glue job runs. We have Amazon QuickSight. This is basically a visualization tool, a cloud native serverless BI service. You can build interactive dashboard and visualization, ML power analytics, so you can do anomaly detection and forecasting. It has spice memory. Basically, you can bring your data from the source to the QuickSight so that it's much more faster. You can connect to Athena, S3, Redshift, RDS, and more. You can also embed your analytics onto the apps, and pay per session pricing is also available. Kinesis is basically the real-time data streaming, just like Apache Kafka. It has three things: data stream, custom real-time data processing with shards. Firehose is basically the message delivery. So all the data that comes, if you want to deliver somewhere to S3, Redshift, or OpenSearch, you can do that. And you can run SQL queries on top of the real-time data using data analytics. So this is the Kinesis. It's not part of this, but in future maybe I'll create some project on this also. Okay, AWS Lambda compute service, databases also we have to cover. uh, RDS is our relational databases like MySQL, PostgreSQL, Oracle, SQL, MariaDB. All of these are available. Automated backups, patching, and scaling is given by AWS. Multiple AZ available, read replica for read scaling. So this is the database as a service given by AWS. DynamoDB is basically the NoSQL database uh, with key value pair and document. We might not use this that much. Single digit millisecond latency to any scale, on demand or provision capacity is available, and global tables for multiple region replication. Redshift we already Redshift we already looked into it. It's a data warehouse for AWS, columnar storage for massive parallel processing, Spectrum for SQL S3 queries. We looked here. It was here, I think. Yeah, Redshift Spectrum. And RA3 nodes decouple compute from the storage, like if you want to separate it. And AWS DMS migration service, if you want to migrate data from one source to another source, you can easily do that. Supports both homogeneous, heterogeneous. So if you want to migrate from on-premise PostgreSQL to RDS PostgreSQL, it supports that, or on-premise MySQL to RDS PostgreSQL, it supports that, like homogeneous and heterogeneous. It also has CDC, so continuous data capture. So anytime the changes happens on the source, it also gets replicated. And you have a tool also available, schema conversion tool for migrating schema. So this is the core of AWS. Again, this is just an overview. Again, in this masterclass, we wanted to mainly cover the tutorial side of it, the theory little bit, also hands-on while looking at the UI, and also execute the project. So I've tried to cover all of this together. If you want the detailed version, of course, you can check the learn section onto our website that goes into the detail, and there will be a lot of modules added in the future with the videos and all of the other things. So that is for that. But for now, for this YouTube video, I think this is good enough to kickstart your career into AWS with a good project available. And this project is quite complicated also, so we were able to cover everything. Okay, now this job is successful. So if I go to my buckets, if I go to gold, I should be able to see YouTube, 3 data, category analytics, channel analytics, trending. This all will be Parquet data available based on the region. So this is done. I can go to Athena. I can change to gold layer, and all of the 3 tables are available. And I can now start querying. For example, let me do this. Okay. Top trending views, top trending days by views. So I'll do select region, uh, trending date parse. Okay, this is the parse date we have. Total videos, total views. mm, average views per video, average engagement rate, unique channels. Okay, from trending analytics, where region is equal to US, order by total views, and let's just say limit 10. Okay, so this query will give top trending days by the views. So if I put this, is this, okay, here. So based on the days, okay, so this is the, so this day is the top trending for the US. Then after that it was like, 11th, 11 2, then 8 2, then 10 2. So total video 17, total views are this, average video per average views per video is this much, engagement rate is high, unique channels are 17. So like this you can also find top channels. So let's say this is a query, I can get all of the information, channel analytics and US. Okay, I'll do this, and these are the top channels in the US. Let's say, let's do India. Okay, IN, and the T series is the top channel with these number of views. Then we have the Marvel Entertainment, Fox, Amit Badana. This is like 2018 data, so makes sense. Speed Records, Gold Mine, Z Film, YouTube Spotlight, Sony Pictures Entertainment, everything. Okay, you can also category performance also you can check. So if I do based on the category, okay, and get all of the metrics. Oh wait, yeah. So entertainment is the highest category. Then we have the music, film, animation, music, comedy, news, politics, people. So most of the category are the consumed by the YouTube people is the entertainment. So I'm understanding, okay, entertainment is a good way to start. Then we have the music, film, animation have, so like that we have, in India it's entertainment. You can also go with the specific region also. In GB it's music, then in US it's entertainment again, people, blogs, music. Okay, so we can understand, okay, what is going on. We can also do the cross region comparison if I want to do. You can see average engagement, highest engagement is in the GB, lowest is in the India. Data points are this much, cumulative views, highest views are here, and the lowest are actually here in C here. Okay, so this is cross region comparison. You can also check viral channels like this, like you can get the channel title, engage that from group by having region. Wait, let me run this again. So highest viral channels like trending in 3+ regions is SpaceX, then PewDiePie, Universal Pictures, Paramount, Vivo. All of these are the viral channels. Okay. Okay, so these are the analytics, right? Simple basic SQL queries. Again, you can chat GPT all of these queries, write it and get more analytics. What do we want to do? We want to move to the next section. Again, these are the basic stuff, so we don't want to spend time. We want to learn AWS, so that is what we are focused on. Okay, so last thing, okay, we have to do here is this one. AWS Step Function. Okay, what is AWS Step Function? It's like an orchestrator. So AWS Step Function is a serverless visualization workflow orchestration service that enables developer to build distributed application, automate processes, and orchestrate over 220 services using state machine. Okay, so Step Function, basically it starts like this. You can have a workflow like this. You will choose your path, then call the HTTP endpoint, extract something here, do invoke Lambda function, do something. Basically, if you know about Airflow, similar to that, but using AWS services, so you can orchestrate the entire thing. For that, we will go to Step Function. Okay, click onto the get started. uh, you can run the simple hello world. You can choose existing template or create your own. We will create our own. So wait. This is what it looks like. Okay, these are the different actions available on the left that we have. Then we have all of the flow available, like choice, parallel, add separate branches. If you want to map out something, we want to wait, success, delay. There are also pattern available, like process ASV file from S3. You can directly drag that and put the information, write information, do the configuration from the design angle. And then there is a code also. Now, before we do anything with the AWS Glue step function, we also need a IAM role for this, because it should be able to access all of these services that we are calling. Like we'll be calling AWS Lambda, we'll be calling Glue and the SNS. So we have to create an IAM role for that. So what we will do, we will go to IAM. Wait, let me just see. Yeah, there's IAM available. We go and create a role here. Wait for this. Yeah. Then inside the role, we will find step function. Click on to next. Uh, Click next. Wait. Okay. What is this? Why it is giving lambda role? Step function. Okay. Go to next. Then just give the name as YT data pipeline step function role dev. Click onto the create role. Find that again. Click here. Add inline policy. Okay, and paste this to the JSON version. Okay. uh, Invoke here. You will need to add account. So I will add my account here and here also. So it invokes, gives the permission to invoke Lambda function. It gives the permission to start AWS Glue job, and also publish messages to the SNS notification. Okay, next. Uh, Policy name, data pipeline, SFN access. This is done. Okay, so now we will go to step function. Okay, to write step function, we have a JSON available for that also. Let me create a new folder here. Step functions and pipeline orchestration.json. So first of all, we have the comment. After that, we have the start at. This is a standard format, like a start at, where you define where your actual execution start. Then within the state, you define all of the states that we have. States are basically invoking Lambda function, executing glue job. All of these are the different state. Okay. So the first step is ingest from YouTube API. This is a custom name that we give. Okay. Type is task. Resource is a AWS ARN Lambda invoke. And then there are parameters. Parameters are basically the function name. So here we have to define the ARN of the function. That can be that you can go to the Lambda function. This is our data pipeline YouTube ingestion dev, and you can copy the function ARN and paste it here. After that, we have the payload, so triggered by step function that we have to add, and this is the execution ID context variable. So all of the when this executes, right, it will keep the execution ID for its reference, and the result of this will be stored inside the ingestion result. This is again custom name. You can keep whatever you want. Okay, so this is your result path. So after the result path, we want to retry and catch. This is like a airflow only. So if you want to retry, okay, you define the different errors that it can catch. Maximum retries it can. So what whenever this happens, it wants to retry after these interval seconds, and in case some error occurs, okay, it will store that error information into the this part. And then we defined our next. What the next thing we need is the wait for S3 consistency. The reason, when we execute our YouTube API, it stores data onto the S3. So we want to wait for some second, okay, till the data is added to the S3. So wait for S3 consistency. This is a state available into here also. If you go to design, inside the flow, you will see choice, parallel. There is a wait available also. There is parallel available, pass available, success and failure available. The same way, wait for the type is wait. The type of this, if you see, if I drag this here, okay, if I go to the code, you will see the type of this is wait. Okay, so we are just using the state type wait. Seconds 10, comments is just wait for the brief wait for the S3 consistency, and we define the next, which is the process in parallel. Again, this is a name given by us. Process in parallel. We use type as parallel. If I put this here, you will see inside the code, the type is parallel. Parallel basically means I want to execute two different machines. Okay, this is just a simple comment. Then we have two branches. One transforms the lambda function one over here, and second is for the glue job. So here we will have to define few things. So starts state is transform data. Inside this we have the task, which is like lambda invoke, same one, nested JSON. Here we have to define the write ARM, which is JSON to Parquet. Let me copy the ARN for this and I paste it over here. Triggered by step function, we will put the result here. Again, we will do the retry. End is true. Then for the glue job, task is glue job run. We will have to define the glue job name here. So I'll go to the glue, and the glue job is bronze to silver one. We will have to let me check if it is a job name or the ARN. Okay, so here we have to add glue job name, and all of these arguments that we were passing. So arguments, we can find it here. This is my bronze database. Wait, let me copy from here only. Okay, a bronze database, bronze table, silver bucket, silver database, and silver table. Okay, result path, we store it result. We also put this into retry. uh, Both result is added over here, and next is the run data quality check. The same thing, we define a task as lambda. Here we will have to add a data quality one. So I'll go to lambda, data quality pipeline dev, get the function ARN, paste it over here. Payload silver, this is fine. Tables, these are simple payload. Result, yeah, we will have to update the silver database here. Okay, YT pipeline silver dev. This is fine. All of this is fine. Result part, DQ result, evaluate data quality is done. We have a choice. If the data quality is passed, Boolean is true. Then next is run silver to gold, or we notify the failure. Run silver to glue job. We will have to provide the job name here. I'll go back. Silver to gold. Job name. Silver bucket, gold bucket, and gold database. Okay, updated this. This is fine. Again, retry, catch error, notify success, SRN topic. Let me copy this. SNS of SRN. If you want to notify if it is successful, if it fails, okay, publish. Here also and here also. Okay, and here also. Okay, so in all of the places I just have to provide the uh, SNS SRN for notify success, notifying failure, transform failure, DQ failure, gold failure. Okay, these are the different failure states I have added. I think pretty much all we have done. Pretty simple. Let me just go to the step function, add this here. See, it created the automatic graph for us. And what we will do, we will click onto the create. Permission for this cannot be generated. Stage SNS published. Notifies the topic ARN is invalid. Why? We have copied the right ARN. For step function start, let's just go with this and see if we are getting any error. Detected at name, satisfy members must have one name. Okay. Name, function name. Okay, all of these are fine. What is the issue here? Error creating your state machine value one validation error detected. We have any issue here? Hmm. Is fine. Notify. Here is fine. Alert. Dev. This is fine. This is fine. This is also fine. Oh, okay. I haven't added the name of the state machine. Oh. We will give the name as YT data pipeline orchestration config. IAM role, I think we have to use this one. And I think, yeah, we're good. Okay. Let's just do the start execution. We don't have to do anything, just start execute. Graph level view, we will see this now. Okay, so it ran the first function successfully, ingest from API, waiting for the S3 consistency. This ran. This might have started running, so you can actually go and check. So bronze to silver, there will be one more run here. Okay, it is running. So all of these things are automatically happening. Transform, it might have already run. So inside the transform, is that JSON to Parquet. This already ran. This is running, so it will take around 3 minutes to finish this. So this executed automatically. This executed. This will execute. If the data quality check fails, okay, it will notify us over the email that okay, that the data quality check failed, and then it will move to the next one, okay, which is evaluate the data quality. After that, it will go to the run the silver glue, and then it will give us the final notification. Okay, so let's wait for this to complete. 54 second again. While this runs, I just give you the overview that again, this is quite complicated if you are looking at for the first time, and you don't have to write all of this by yourself. All you can do is just explain in this age, explain AI about your entire context, that I have created this lambda function and this is my architecture. Can you give me the state machine for AWS Step Function, and it will generate the entire template for you. You, all you have to do is just replace the right things at the right place, and you will get the entire thing. Earlier we used to have, trial and error version where you used to spend time on UI or on the JSON to modify things and then execute. But these days the code generation part is completely automated. You don't have to do anything by yourself. You can actually automate this entire project using just Terraform script also. But again, the goal of this project was to teach you on execution side of the AWS from the console, and also teach you about AWS from the scratch. So this was the core idea of the project. That is the reason we spent time onto this. Again, this is running 2 minutes 25 seconds. This will success. Most likely what will fail is the data quality check. We haven't done the data quality check on our side, so this will do the data quality check after it puts the data here. If there is any error, we will get to know that. Okay, 1 more minute. Okay, so this job is still running. I think it will success in few seconds only. um, New data might have got added, so just waiting for this to finish. Okay, this is successful. So this will get the result here, and this will do the data quality check. Okay, okay, so done, data quality check failed. There was some issue here, looks like. Failed logs, let's check this. Lambda input, no module name, AWS Wrangler. Okay, the issue might be with the Lambda, not with the data. So let's go to the quality dev, add the layer, go to below, edit, add layer, AWS Wrangler. Hmm, we can add Python 311 SDK pandas. I think this should be fine. Save. We can test it here. We did not test this actually. Pandas. Not sure about Wrangler. Where is that? Let's see. Okay, how it should actually work. We can rerun this, I think. Action, test state, start test. Okay. When the publishing the topic error type, test input state definition, invalid parameters. It's not executing this. Table view. Let's just test here itself first. Make sure this is deployed. Test. Create new test event. Test. Save. And invoke. I think it requires a custom parameter, so might not run it. Uh, Invalid parameter topic name. Publish operation topic name parameter. Okay. Okay. I think topic. Set this topic name issue SNS topic, right? Uh, it is coming from SNS topic ARN configuration environment variables SNS alert topic ARN. I think this is fine. Let's just check one more time SNS if we have the right topic ARN. This is the ARN. Okay. Uh, okay, yeah, we had a wrong ARN added. So I copied the right ARN from here. That could be the case of here also. When we created our machine, we might have added the wrong ARN. I go to state machine orchestration, I'll edit it here, go to code, and here I think we added the long one. Topic ARN is this. Alert stay. I think this end part is not needed. We can remove this end part. Okay, okay, this is done. This is done too. Is there any other place? It has. Function name is fine. This is fine too. Okay, I can save this. Hmm. Okay, let's execute this again and start execution. Okay, so again, this is start from scratch. Most likely we had issue onto this lambda. Now if we test it, I think it should work. Uh, it is failing. Publish operation is not authorized to perform onto this resource. So I think it's a again the IAM we might have to update it before it reaches configuration permission this IAM role. Basically, I'm going to the IAM role of this, and I think we created inline policy, but we have to update this topic SNS, this one. Yeah, this is not right. This is we have to put here also. Next, save changes. Now, if I test this, okay, YT test. Let's test this. I should have tested this before. I thought it will work. I'll say, oh, now it's working. Okay. Total checks pass 0. That's fine. If an error occur, access denied exception, Athena get work. After you admission, you have to update the permission. So it is not able to access the Athena. We can add a permission here itself onto the data pipeline lambda dev role. Athena for let's just give Athena full access for now. And let's test it one more time. Total checks passed. Let work group Athena work group resource. Weird, we just gave the access. I think it might take some time to reflect maybe. Okay, let me just copy this to Flow. Okay, and what we will do, we will copy the inline policy also. Basically, if any error comes, right, this is uh, you put this. Make sure there are no sensitive data right now. There is nothing. So again, we have to add this. Give me complete policy, and this will give me the complete policy. I just have to paste this as it is. Copy, paste this. Next, save changes. Okay, this is done. Now let's test it. I gave the access. What the hell? Work group get work group on resource. Is this? I think it might be issue with S3 because we have limited permission onto S3. Could be that. Let me test. Uh, access denied exception. This will run. Oh, it's weird. Still getting the same. Still the same error. Always work with a specific group. The action you explain the work group ARN. The key change resource with the explicit work group primary default and a work group replace primary with your actual work group. Data load needs the query execution. Your custom work group not primary. Okay, let's see. Let's go to Athena. Oh, work group is primary. Okay. I don't think there's any issue with that. Default Athena work group replaces by and data column needs the query execution. This is weird. Should not happen. And this will execute. Let me save this. Save changes. Let me test this. Same exception, add exception. Let's just add admin permission for the test to verify if this is a permission issue or something else. Same. Okay. Wait, let me just put the code. This is my code. Even after adding admin permission, still getting the same issue. Might be some issue on the code level. So default workflow implicitly you need to call explicit workgroup by Athena query. Update the read SQL query. Okay. Okay. We have not added this the Python on update your S3 location and use them with the query. Give me complete code. Internally to validate the fetch output query, even with the resource IAM, some includes requires to be attached and refreshed. Okay. Okay. So that means uh, this needs to be updated. The work group, the query location. Work group. Primary is the work group. Athena S3 output. Add Athena work group S3 output and region environment variables on the top. Okay, let's try this. Okay, data quality. Put this. I'll deploy this. I'll go to configuration, environment variables, edit, and put Athena work group. Uh, Primary, put Athena S3 output. As this one, and region AP South 1. Athena, I plan to Athena. AP South 1 to Athena query result. This is fine, I think. Okay. Region is not possible. Let's just put this as it is. Okay, deploy this. Test this. Come on. Okay, now it is passing. Okay, so I think the issue was most likely the permission issue, or maybe we had to explicitly define the Athena. If I remove the admin policy here and AWS policy here, maybe it should work again. So if I test it, yeah, it was not the policy issue, but the code level issue. Okay, this is running. Okay, SNS authorization DQ failure. So data quality was successful, but there was an issue in this cause data pipeline. Where is this? Notification SNS publish. Let's check this. SNS publish for assume role. Okay. Notify DQ failure. Okay. Find notify DQ failure. This is fine. A state publish. This is exactly same SNS ARN. Topic ARN is fine. I think. What's the issue? This is subscription. Okay, subscription is this one. This is topic one. I will copy this. This is ARN, right? Okay. And this is pasted here. This is fine. Subject is fine. This is fine. What's the issue? What's the issue? Data pipeline because no identity based policy allows publish action. Okay. That means if inside the config we have IAM policy available, which is this one, and if I go to IAM role of this and check if we have permission given, yeah, we have given. Let me edit this. And put the SNS ARN proper one. Okay, this was missing, I think. Next, save changes. Okay, now I have given that. And if I tell to retry from failure and retry execution, starting retrying. Okay, now okay, it's working now finally. Oof. Okay, so this was successful. This was successful. All the test cases passed through. So if I go to Gmail, I will say I will get this warning: data quality check failed because uh, there was something happened, but data quality check actually failed because of the some reason. Okay, what is the reason? Quality pass 0 check 12 check reader false and occurred with access denied. Okay, the same issue happened on the Lambda because of the this part, and that is the reason it failed. I think we have fixed this issue. So if we do the new execution and start the execution, now the entire pipeline will be successful. Okay, let's wait for that and let's see what happens. I'll wait for this to complete, and if it is successful, I'll show you. If there are any error, we'll continue from there. Again, I ran the script, but there was an issue, and the issue is still related to some permission that it is not able to read this bucket, and looks like our IAM onto this data pipeline, okay, does not have permission to read uh, the, what is that? Let me find this. Yeah, this does not have permission to read the S3 bucket where our Athena results are being stored, because inside our inline policy, if I edit this, we have just added uh, silver and the bronze bucket, but we also need to add the information about the Athena, okay, over here. So just do ARN this, and where is Athena, the bucket name, this one. Okay. Result star comma, copy this, paste this, and then save it. Okay, and if I think test this state again, maybe data quality is still not passing even after updating it. I go back, I fetch this. Uh, YT clue result S3. Okay, let's just add this into the step function. IAM also. Let's just right now add a complete S3 access to debug this S3 full access. And if I now run this, start test, still fails. Input is fine. DQ result is failing. Table view. Access denied for this. Sure, bucket is encrypted. Cannot read, access denied. But yeah, the full access is given. I think both of the Lambda has full access. Let me give Lambda also S3 full access for now to check if it is a permission issue. Okay, and I will run this one more time and see if this is working properly. New execution start. Okay, let's just wait for this and I'll continue from here. So in this one I can see the data quality check passed, and now it is running this glue, which is this one, the second glue job that we had, so which is silver to gold one, and it might be in the running state right now. If I execute this is running, so it will take 1.5 minutes, and this might send, if it is successful, notify us success, and we'll receive the successful message. The most likely the issue was with the permission. I added the full access, but I think in the both step function and in the lambda function you will have to give the S3 access to the resulting bucket, so that it can access the data from there and execute it. Okay, so this was the issue. I think on the step function we faced a lot of issue because we were orchestrating everything, and for that we also need to provide the right setting. When we access when you know execute all of this individually, it works, but when you try to execute it together, there are chances that some bucket might not have access to each other, and that is the reason we have to provide the all the permission. So waiting for this to finish, I think this will finish in few seconds, and we will have our this completed, and we will receive the final notification. Right now we received all of the field notification only because of the denied access, but now we will receive a final message. Let's just wait for that. If it is complete, this in running state. Once this is done, I think we are done with our project mainly, because this will be done also. We use SNS, CloudWatch, IAM for most of the things, so our entire project will be complete. And we also covered most of the things here about the AWS core for data engineers. Again, if you want to learn more about AWS, I have few projects available online. You can check them out. If not, best is you can prepare for the certification. I'll recommend you AWS certification if you want to deep dive. The simplest certification to start with is the cloud practitioner one. That will give you the basics. But if you want to jump to, you can prepare for AWS Data Engineer Associate. That will help you to learn more about data engineering services. You can just YouTube, you will find bunch of tutorials on data vidya also. If you want to learn basics of data engineering from start to end, we provide everything. So this will also help you. I think our execution is complete, and we received the notification pipeline completed successfully. So that means if you check the state, notify success is executed. Okay, after this, so our pipeline is running fine. So this was everything. We have completed this entire architecture. Let's just revise it again. What happens? We have data coming from Kaggle dataset. Initially, we created buckets, and we, using the bash script, we uploaded all of this data to Amazon S3. Same way, we ingested, created a Lambda function and ingested data to the Amazon S3. Once that was done, we wrote the Lambda function to transform our raw JSON to the Parquet format. Same way, we wrote the glue function in PySpark to transform CSV in the JSON file and put that into the Amazon S3 and the glue catalog. Here also we executed crawler onto the glue or raw data so that we could understand what the raw data is. Here we get the clean data. We had the data quality check that just checks the issue with the data, if the views count are less, if there are no lot of null values and all of the other things, and sends the notification according to that. Once that is done, we do the gold layer onto Apache Spark, where it reads both of the data, creates and aggregates them into the three different categories, creates table onto catalog, put that onto the Amazon S3, and we can query that using Amazon Athena. Same way, we have step function that executes the entire thing in one shot. We faced a lot of issue over there, but we were able to tackle it out using AI and you based on some common understanding, and we fixed it. So the entire project is completed. Now next step, what you can do, you can clean your entire AWS account, basically delete everything. If you want to delete it, if you want to keep it, you can keep it. I don't think you will get charged because we haven't like automated this entire thing right now. So you can keep it, you can delete it, up to you. If you want to keep clean it, you just have to go to the each and everything that we did. Go to IAM, delete all of the resources, go to S3, delete all of the buckets, go to Lambda, delete, and go to Glue to delete the ETL jobs. Just delete it everywhere, it will clean it up. Okay, so this was everything about the AWS. Again, this is just an overview of AWS. I just touched a few services, but if you want me to create part 2 of this, just do let me know. Probably I'll upload the part 2 of this video onto the my website itself, Data Vidya, onto the cloud infrastructure. So you will find part 1 and part 2 and multiple parts of this and individual videos for all of these different things here itself. Do check that out, and happy learning. So this was everything, and I'll see you in the next video. Thank you.